Introduction. This model is structured, ordered, interrelated, and consistent. The signs of a good model. It explains geologic mysteries. For example, Tectonic's driving mechanism, Nastapoka Arc in Canada, Bermuda, hotspots in general, the microcontinent of Zealandia, the microcontinent of Greater Adria, relative ages and ages of the Earth's layers, the mid-continent rift in North America Mackenzie dike swarm, gravity anomalies, magnetic anomalies, fault system interrelationships such as the New Madrid seismic zone, and even the Theia impact. This model explains all important chronologic geologic events. This model agrees with aspects of the current model, and if not, can explain how the current model came to be. This model is supported and initiated by the results of a 5-year field study in Lower New York, USA, and by an intense analysis of Google Earth. This model is verified and guided by many amazing fractals in North America and around the world. I'll explain what fractals are later. Google Earth. An intense analysis reveals the following about land masses. They are related geologic structures, some of which have broken up. There were 7 land masses or structures. One has disappeared into the Earth. They are presently attracted to a zone between India and Russia. They show details of internal stress and flow-like movement. They show details from amazing fractals within them, such as history of internal stress and flow-like movement, history of high-energy tectonic geologic events, faults that are based on the character of the fractals. Google Earth findings. They're shown in the following: William Pagano's January 2019 YouTube video titled Plate Tectonics, Unraveling the Truth on the William Pagano channel. Refined in much greater detail in the PDFs found in the link below. To see the PDFs, be signed into a Google Drive account. Otherwise, you're not going to see them all. And it'll make more sense, obviously, if they're all there. The above link is also found at the end of the YouTube video description. Okay, part 1 of this presentation is Geochronology of the Earth, beginning at 2.5 billion years ago, 2.5 BYA, up to today. The findings are guided and refined by fractals and geologic structures found on Google Earth every step of the way. And it's also guided and refined by published geologic literature every step of the way. Okay, this presentation is going to be broken up into parts. Part 1A is Pre-Cambrian Era Geochronology. This is from 2.5 billion years ago up to 541 million years ago. That's when the Cambrian started. The findings are guided and refined by fractals and structures found on Google Earth every step of the way, and the findings are guided and refined by published geologic literature every step of the way. Have to stress that. Okay, the next several slides are about refolding and its relationship to the following. The formation of the supercontinent of Columbia, which formed about 2.5 to 1.3 billion years ago according to geologic literature. Refolding and its relationship to the formation of the supercontinent of Rodinia, which formed about 1.3 billion years ago to 900 million years ago according to geologic literature. Refolding and its relationship to the formation of the mid-continent rift, MCR, in North America within Rodinia, 1.16 to 1.09 billion years ago according to geologic literature. Refolding and its relationship to fractals, which I'll describe what they are in detail later. Okay, this is probably the most critical slide for all my findings. It's the foundation to everything. So have to make this very clear. And this is going to be repeated many times as sort of a reminder and everything like that to hopefully make things clear. So just a general background. Structures are things that are stable. And, you know, on any level, I mean, the human body is a structure. It's got 2 arms, 2 legs, a head. And when it comes to the Earth, a structure is stable. So the things that you see on Earth, I'm claiming are structures. At least at one point, they've since become broken up to some degree, some more than others. But I'd like to explain how they came to be. So I'm going to make what I call a claim at this point, because as of now, it's going to sound crazy, but it's going to become quite clear that it's true. Okay, the original Precambrian crust, the oldest crust, foundational crust, deepest crust in general, of the Earth was a section of a chain of refolds consisting of 7 interference refolds. That's what this diagram shows. I'll be there in a sec. That was likely ejected off a large celestial body or planet after an asteroid or planetary impact at approximately 1.3 billion years ago. The section of the refold chain that became the Precambrian crust of Earth was one of many refolds chains in a large system of refolds that were ejected into space. An introduction to refolds is shown here. Okay, so as we see from this diagram from Twiss and Moores, 1992, shows the formation of interference refolds. So how they would come to be, there's many types, but this type is the type that formed Rodinia, which is the foundational crust of the Earth. So if you look at this, I said impact that assembled Columbia approximately 2.5 billion years ago. This red arrow would be the direction of the impact on the crust of the large planet. This is on a very large planet. This is elsewhere. Okay, very important. Because as you'll see, there's a large system of these things that formed, and Earth is just part of one little column, which I circle in blue. And I'll explain it's really the yellow thing that formed Rodinia. But anyway, so here's this big impact at 2.5 billion years ago with the red arrow. And it deformed a relatively thin crust in order to deform it in this style and bring about these refold, interference refold types. You know, there has to be certain conditions of crust that's thin and everything. So you can see how it's even drawn in thin, and it's got the point there, it comes down. This is in profile, comes down like this, goes like that. And, you know, there's at least 7 of those points because they later refolded to form these interference refold structures. But where they come to a point, whether it is here or on the other points, which are, you know, behind, I'm going to draw a dashed hidden here. And, you know, there's a point here. So anyway, at those edges is where the refolds form, but that comes from, let me explain here, an addition of what was, I'm calling another impact that assembled Rodinia, which is here. This is Rodinia, approximately 1.3 billion years ago. This was more or less perpendicular, this asteroid direction. There was probably a lot of impacts, but this big one was enough to take this the land, which was folded from the major impact at 2.5 billion years ago, and it was able to refold it at about 1.3 billion years ago. And the addition of the 2 folding types, folding plus refolding, causes an interference refold structure, which are shown in the yellow here and shown in the blue. Now, I am claiming that Rodinia basically looked like the yellow, and it is subdivided into the refolds in the blue, as it which really represent the continents. And you can see that at the edges, here's the edges. It's at the edges that I talked about over here. See those points? They are always forming these crescent moon shapes, or the yellow structure, which is just basically the same as the blue. It's just more tightly refolded. You can see that those legs are more distinct because it's more tightly refolded. And there's always a closed end and an open end. The closed end is at the point. Open end is where it fans out in the V shape. So like here, and that would represent one of the land masses, one of the 7 land masses or continents of Rodinia on Earth. I should also note that because of the direction of stress in blue here, it is, well, for a number of reasons, but it's easier to break off a column, which I call circled in blue. I could have also circled the column of the yellow type refolds, which are more tightly refolded. But that's a column. That's where it's most easily going to break, given that stress direction, and just given the general deformation style. It's definitely going to break along the edges of the columns. You know, as I call a column going in that long direction. Okay, what we have here is a Google Earth image of South America. South America is one of the 7 land masses I discussed that are actually refold structures that were shown in blue on the previous diagram, and all a part of the large structure of Rodinia, which was shown in yellow on the previous diagram. What we see here says a profile of South America demonstrates an example of the closed and open-end sections of these 7 refolds. The expansion of South America is due to unloading on its open end. Okay, so what does that mean? We're going to look at an imaging of South America that I'm circling here from a geophysical study. And I talked about this closed end is on that corner. Remember I was talking about the edge? And then you get the crescent moon in this direction. So that's what we're looking at, is the closed end. And if you look at this in profile, in the red below, I'm circling it now, what you have is you have your closed end here. And originally, if you look at this end that I'm highlighting now, this end of the blue arrow. Now, let me explain one thing. Boudins, which are these football-shaped things that I'm highlighting here in the orange, these things, Boudins, are formed in an extensional environment, and extensional environments are on the edges of structures and stuff. The tensional fibers on the very edges, or near the edges of structures, or whatever. You know that from engineering, for example. So at one time, this was the outside where these orange Boudins are. It was on the outside of the structure. And later, as you can see, I'm saying that the younger yellow Boudin path is a duplication of the western orange Boudin path right here, except for the effect of the pull shown in the red arrows. So if you look at this, they're exactly the same. In fact, even where the Boudins are, the Boudin paths are shown in the orange and in the yellow. Now they're very hard to see on Google Earth, but I was able to see them with a great deal of intense studying and everything. And I was able to get this diagram together. But you can see that basically if you take this orange at the red arrow here that I showed, and you pull it in this direction, you will get the yellow Boudin path as shown. So what does this all mean? Like I said, at one point the orange was on the outside of the structure. So if you go back to this cross section shown in red, and basically the structure was probably more tightly folded here. I'm outlining the older structure characteristic here. See these 2 red lines? This is the open end here on the bottom, and the closed end, as you know, is on the edge. So if you project up from this point that was once on the outside, it now appears on the inside as you see those orange Boudins. And the structure unloaded and became like wider. It fanned out wider in the path of this blue arrow, and it ended up as you see it today in the geophysical diagram above. So eventually these orange Boudins in the center, basically, of South America, they got sort of like a slingshot. They got ricocheted outside off the mainland where I'm circling here on the east end. And there's 2 different Boudin paths, one in red, one in yellow. And I put the Boudins color-coded in red and yellow. And basically, what I'm highlighting now in red was from the red Boudin path. And because I was able to see these, this must have been resting positions for a while, so they're easier to see. Now I'm highlighting the yellow. So that came from the yellow. Based on the positions they're in, the Boudins rotated counterclockwise as units and also as a pair coming from the point of ricocheting off the mainland. I call it the tear off due to rotation, right here. From that point, they rotated counterclockwise as a pair. There was a resting position, as I said, in the middle at the north end. And then today, the red Boudin is what is now Honduras, or part of it is Honduras. And where the yellow is like in the ocean. But you can see these if you look carefully on Google Earth. So as we know from the concept of fractals, if South America looks like this, also based on the character and what I've seen through this study, they all look like that, all 7 of these subdivided refolds as part of Rodinia. And, of course, they're all on the relative same order of size. One's not 50 times bigger than the other. They're all more or less the same size. And again, some have gotten broken up. South America is very intact still. And everybody knows South America was attached to Africa, and they fit nicely. It's very obvious, even in the, kindergartner can see that they were once fit together, and they've drifted apart along the Atlantic Ocean. Okay, this slide is a little bit of review material and some new material. So if we look at, as a review, the supercontinents of Columbia and Rodinia formed by impacts on a very large planet. Okay, so the impact, according to this model that assembled Columbia approximately 2.5 billion years ago, would be in the direction of the red arrow to deform the land as shown in this style. And eventually you're going to add another impact, eventually a large one that was able to refold the land from an impact that was more or less perpendicular to the first one. And this was about 1.3 billion years ago. It allowed you to get these interference refold structures. And Rodinia was one of the many, probably in a large zone of these things on a very large planet. And I'm claiming that Rodinia, which is shown in the yellow, is subdivided into the structures that are shown in blue. I mean, that's kind of a concept of fractals where things are represented on different scales. So if you magnify the, see those red profiles of zigzag profiles, they're just represented, they're on different scales. They're within that yellow, just smaller. So that's what makes the subdivisions of the blue inside the yellow. All right, here's an example of a small scale one that's shown in Lower New York State in the photo here. So this is the closed end here, and the open end is in the ground, but it's on the other end. All right, and it probably widens up on the open end. All right, over to this diagram here, you see what the Rodinia type interference refold here in yellow. And there's a fractal of that to the right here, circling it. And at this point, I have to describe what a fractal is. Fractals are often shown after high energy events. And they are basically have guided me through this entire study because, at least from a tectonic standpoint, they show these really, really high energy events such as the breakup of Pangea and all that. And I'll get into the particulars of what this fractal is showing later. But you can see that the it's just an energized version of the interference refold structure to the left. So it's representing an interference refold structure that's highly energized, right after an event, following an event. And the borders of these fractals are formed along like rivers, lakes. As you can see in this section, that's the edge of a lake or whatever. Any kind of cliff or things you can actually see. And a lot of times it's even like a discoloration in the vegetation. And among other things, we'll see more about more details of fractals later. Okay, so If we look down to the lower left, there's something called the Mid-Continent Rift that's found in the heartland of the United States, basically central U.S. It's pretty big. It goes from way up by Lake Superior down to Alabama or so. And you can see this is, again, sort of a crescent moon shape here. And it extends down, the tail extends down to the southwest and all like that. But you'll see how it's all related to these interference refold structures. But right now, okay, here it is originally in what I'm calling here is Rodinia, that is sort of unraveled, like the thing was on the globe of the Earth and all the continents were together. That defines Rodinia. And if you pull it apart, you're basically going to have this structure right here I'm circling, minus the top that was unstable enough not to survive all the way to Earth. Earth Precambrian crust just includes this section here. And you're saying, okay, what are these legs? Well, they're down here, part of the Southeast Asia refold. Both legs were anchored to the inner Earth at one point. Now there's just one leg anchored there. We'll get into more of that later. But you can see the crescent-shaped refold boundaries and all. And it's showing the Grenville associated fabric. The Grenville fabric was formed during an orogeny from 1.3 billion years ago to 1.1 billion years ago. And published geologic literature shows it in orange here. And I take this, among other studies, and I put it into my model on the left, drawing an arrow here. And it's shown in green. The locations where the orange stuff is in the green. The Grenville fabric is shown in green on my model. And there is a pattern here. It does, in fact, look like the result of an impact, because I'm saying there's a perpendicular element of the Grenville associated fabric going in this direction. And that is shown, you can see a lot of that element. I'll get into a better diagram later, more blown up, but you can see a lot of these sections oriented in that direction. And other sections are going to be along borders and parallel or subparallel to the crescent moon shape. So this mid-continent rift is very, very important for this study. It really kind of shows a lot in regards to validating the model and showing some very intricate details, which you'll see coming up. So again, just to reiterate, this perpendicular element of Grenville-associated fabric does appear to be like showing a shortening of the long axis of the refolds, which are now more compressed in this direction. Probably before the impact they were straight or like this, but as they got more tightly folded, they became more crescent moon shaped, more C-shaped. Okay, this slide shows introduces some new material. It's impossible not to jump ahead a little bit, but we're going to be talking about what's new on future slides, and it's all going to become clearer and clearer. So as we start with the text box talking about the supercontinent of Columbia, geologic literature says Columbia existed 2.5 to 1.3 billion years ago. Geologic literature says an orogeny from 2.1 billion years ago to 1.75 billion years ago assembled this continent. This assembly took place on a very large planet as per this model. This orogeny was the result of an impact on the very large planet as per this model. The orogeny likely caused nap zones, which are areas of great land displacement. Nap zones of tremendous folding. See below left. The first snowball Earth took place at approximately 2.2 billion years ago as per geologic literature. So these snowball Earth events occurred with some lag time after these major asteroid impacts. Geologic literature says Columbia broke up 1.8 to 1.3 billion years ago due to tectonics. This was likely tectonics extension on the very large planet as per this model. Geologic literature states that crustal thinning occurred 1.8 billion years ago until 800 million years ago, called the boring billion. Causes for crustal thinning in chronological order from 1.8 to 0.8 billion years ago per this model may be the following. 1. Tectonics extension and associated erosion on the very large planet from 1.8 to 1.3 billion years ago. 2. Refold formation by arching approximately 1.3 to 1.1 billion years ago after a second impact at approximately 1.3 billion years ago that was perpendicular to the first impact on the large planet. 3. At approximately 1.1 billion years ago, refold chain structure and arm stretching in outer space, here comes the new stuff, to stabilize the double refold chain structure. The second refold chain may have formed the moon's crust after likely several refold chains ejected into outer space sometime after the second impact at 1.3 billion years ago on the large planet, but likely at approximately 1.1 billion years ago. And 4, at approximately 875 to 800 or 750 million years ago, the formation of two locking mechanisms developed on Earth at its poles after Earth's crust joined the inner Earth due to attraction. Discuss that later. At 750 million years ago, the Canadian asteroid struck Earth and released the locking mechanisms at the poles and ended crustal thinning because due to the snapback of that locking mechanism, everything was under tension and then it snapped into compression. See other PDFs for all explanations. As per geologic literature, fragments of Columbia may exist today but have been incorporated into the supercontinent of Rodinia when it formed. As per this model, some of the foliation later became borders of refold structures after a second enormous impact event on the very large planet, approximately 1.3 billion years ago, had eventually launched one of likely several refold chains as columns of refold chains, as I described previously, into outer space, one of which later formed Earth's crust as the supercontinent of Rodinia, and another that may have formed the crust of the Earth's moon. Both crusts are in fact similar in age and composition, suggesting a similar event and relationship there. The second impact was perpendicular to the first impact event. After the first impact event associated with Columbia, folding developed cohesive zones in the nappe zone that are described in geologic literature as the following. A. Northwest Africa and South America, which is shown in blue. Atlantica, formed about 2.2 billion years ago. B. Antarctica, Australia, India, Southeast Africa, North China, and South China, which is shown in red, formed about 3 billion years ago, actually prior to the first impact. C. North America and Russia, shown in yellow, Nana, formed 1.9 billion years ago. Okay, now we're looking at the diagram below the text box. It says first asteroid impact associated with Columbia here, I'm circling, showing a plan view of the land deformation. If the asteroid direction is this direction shown, obviously there's going to be more deformation closer to the impact energy, and it will eventually dissipate to nothing up here. And showing in cross section, it forms like a system of waves that come to points, which are the closed ends of the refolds. And I'm just showing where they are right now. Eventually the energy dissipates at one end, and I should note that your concave direction for your refolds are like that, based on where the points are. They're going to fold concave this direction. So what you see here, if you were to flip this profile up that way, see how the yellow corresponds with the yellow. That's kind of what you're looking at. So, there are a lot of factors at play. It may not necessarily be an even dissipation of the folding dynamic, and then there's the refolding event. So it might not be that simple, but basically you have, this is showing supercontinent of Rodinia here on the right. This is like the unraveled version, which was all attached and on the globe of the Earth at one point. And when you unravel it, so to speak, you have this football-shaped thing. And in reality, there's actually legs down here. and these legs are shown here on the basic diagram on the right. Keep in mind that the unstable top cone of Rodinia was lost in the process of making it to the Earth, so you have just basically the heart of this thing, the lower 2/3 or whatever of Rodinia survived to Earth. Now I'd like to go to these old models, geologic literature models of Columbia here. We'll start with the top one first. And there's actually some correlation. You could say that, assuming my model's correct, that they were onto something by this relationship I'm about to show here. Atlantica here, shown in green, which is shown in blue to the right, is united by a crescent-shaped relationship here that I just outlined in blue, and I'm highlighting the blue. This is right here, which is in red on the right. So you see that gentle crescent-shaped section there. And this is Nana, which is in yellow, both here and to the right, related by this crescent-shaped general shape here. And I guess you could say that perhaps the author was saying that the whole thing is united by this red, gentle crescent-shaped relationship. Okay, so if we look at the diagram below, another model, another geologic literature publication. Basically, the entire section of land forming Columbia is shown to be along this axis like this, which is crescent moon shaped again, and very specifically describes what these pieces of land are. But if you look at my model, I join them by the blue. For example, this is Nana here. Could be Russia and North America here, because Siberia and Baltica is basically Russia, Refold, and Laurentia is North America. So I did that with all these blue here. I'll highlight them. And basically after the refolding, there's more severe crescent moon shape. And I just showed that in. That's, from a future event. This is just Columbia, but later you have, I just highlighted right here, this is North America, this is Russia, and actually where these things are located are generally in agreement with the order that you see on the right, with Russia and North America at one end, and Southeast Asia, Southeast Africa and all that for Urgesay on the other end, and Atlantica in the heart of it. So there's something going on here. There's some definite correlations between my model and previous models. So I'll talk briefly about the upper left here. I'm saying fractals capture high energy events. These are fractals. The one on the right side showing two red figures. I'm highlighting one of them. Fractals often show different phases. So the one I just highlighted and this one, both in red, represent Rodinia with the cone still at the top. And what's going on here is Rodinia is embracing another chain refold similar to what Rodinia is, subdivided into refolds here. And what this is in green is the moon. And there's probably even a core in the middle and everything. So it's already, or at least was, spherical shaped. And then the Rodinia chain structure grasped it by putting its arms around it on each side. You can see here one side and then the other. And it's in orbit going to the right. I'll describe why that is. There's these n-echelon structures there that prove that it was moving to the right. There's greater detail later, but it eventually the arms go up, it releases the moon, and Rodinia begins its journey towards the inner Earth, which is shown as the blue globe at the top here. I'm now highlighting it. So just after it released the moon, there's this energized version of what happened in this fractal right here. And then it really starts its journey here in the blue. Okay, just to clarify something from the last slide regarding the relative ages of these of Nana, Atlantica, and and the whole dynamic going on here. So as you know, as I said, this is the direction of the asteroid impact. So obviously it's going to deform the land in waves as such, as you see in the cross section here. So as I was explaining in the previous slide, there's going to be a direction of kinking when it eventually refolds. It'll be in this direction, concave to the left, as I'm drawing down here. So when you flip this diagram up as such, that's what you'll have. Now, being that is 3 billion years old, and it's actually formed before the impact on the large planet, which was 2.3 or 2.1 billion years ago, the associated with the orogeny at the time, the mountain building event. So being that Atlantica is 2 billion years old, that's in the blue over here, and Nana over here, I think, is 1.9 billion years old, the youngest section. So why is the back end the youngest? It's possible that since this was such a high energy event with the asteroid coming in like this, probably on some kind of angle, and deforming the land as drawn in the profile and in the plan section above, there was probably like some kind of front eventually down this way, and the energy dissipated back. So the furthest from that front was associated with the end of the energy propagation, which actually goes this way, like a rebound. So that's why Nana could be like a shade younger than Atlantica. Just something to think about. Okay, now we're going to talk about supercontinent of Rodinia, and things will get clearer as we repeat things again and discuss with more clarity. All right, in the text box it says, geologic literature, Rodinia was assembled 1.3 to 900 million years ago. For this model, this was after the second major impact refolding event on the very large planet. Note that this is the same age, 1.3 to 1 billion years ago, of the solid inner core of the Earth, as per geologic literature, thus giving credence to a large-scale outer space event, which is supported by the fractal from Nova Scotia, Canada, see below right. This fractal shows how two crustal refold chains bonded together after being ejected from the large planet after the second major impact occurred. The refold chain in red includes the Earth's Precambrian crust, where the arms are being released, and it is likely that the refold chain in green is the moon's crust, both in orbit around the inner Earth. Okay, so we'll take a quick look at this diagram on the lower right. So that blue, what I'm highlighting now, that's the inner Earth, and that's attracting Rodinia, which is in red, showing two phases. First phase here I'm highlighting with the arms down. The moon is on the lower part of that as the arms are down and embracing the moon to stabilize the double structure. And eventually the arms, which I'm highlighting now in this other phase of the fractal, they go up, and looks like there's some resistance, but eventually this Rodinia is going to release the moon and head towards the inner Earth. And apparently it's in orbit, because the orbit direction is to the right, because these n-echelon structures, which I'm highlighting here, are such that there's a shear direction to the right. And you're going to see this more clearly on a more complete fractal, but you'll see that orbit direction to the right with more of these n-echelon structures. Incidentally, I talk about the Theia impact here. This actually answers any of the problems that the Theia model has. Um, the Mars-sized body that the Theia impact refers to is actually Rodinia when it collides and attaches to the inner Earth, which I showed in blue. There's that attraction to it. So I'll get into more detail on that later. Just want to introduce that at this point. Okay, back up to the text box here. Grenville orogeny is the collision event resulting from the second major impact on the very large planet as per this model. The second impact was perpendicular to the first major impact that assembled the supercontinent of Columbia as per this model. It was the last event in the assembly of Rodinia according to geologic literature, and can be seen as an overprint within and along the refold structures in this model. Its presence on the refold chain comprising Rodinia appears to indicate an impact dynamic. As per this model, localized extension may be due to arching or refolding dynamics, such as at the mid-continent rift in North America that was formed approximately 1.1 billion years ago, as per geologic literature. See below left. So just to talk about this diagram in the lower left here. Again, the greater arching due to refolding, I'm highlighting here, of the main fabric of Rodinia with its legs like this. It shortened the fabric here, this perpendicular element of the overprinting Grenville fabric in green. It's an overprinting because it goes over everything. It was the last phase in the Grenville orogeny. And you can see that perpendicular element that causes the shortening, and it kind of dominates. You find it in a lot of areas, and we'll look at a better example soon. But you can see it appears to be an impact dynamic that was in general in this area. So back to the text box where I just put the highlighter. As per this model, this collision event refolded the rock fabric created from the assembly of Columbia and eventually launched columns of crustal refolds into space, one of these forming the Earth's crust and another likely forming the Moon's crust. The Grenville orogeny not only created a series of connected refolds forming a large-scale coned refold structure, but may also have provided the glue to stabilize the refold column that formed the Earth's crust, Rodinia, as per this model. The glue may have also had an effect on strong versus weak zones that allowed the breakage pull apart during tectonics later on Earth. Such tectonics were initiated by the Canadian impact. Geologic literature claims that because little is known about the ancient geographical configurations, it is more valuable to analyze fabric relationships of these supercontinents, such as Columbia and Rodinia, that are shown on present-day maps of continents, rather than deciphering geographical configurations. However, as per this model, the refold chain appears to have a preponderance of Grenville-associated fabric that is more or less perpendicular to the long axis of the refold structures in the chain of refold structures comprising the original Earth's crust. That's what I discussed below. This suggests a compressional event that was more or less perpendicular to that of the Columbia supercontinent assemblage. The Grenville fabric that is more or less parallel to the long axis of the refold structures may have served as a path of least resistance along a structural weakness in a stress transfer conduit. See below left. Yeah, sometimes the green Grenville fabric is along the path of least resistance has got to be like along the fabric. And as you can see here, I'm now highlighting right in North America, there's one that goes up against the mid-continent rift. So being that's the same shape as the refold structures, it's probably a path of weakness. And you get them on the borders such as Africa and North America and South America and Antarctica and all down below, as you can see. Okay, back to the text box here. The Grenville orogeny ended with extensional tectonics sometime between 1.16 and 1.09 billion years ago, as per geologic literature. This may have been the refold chain of the Earth's crust embracing the other refold chain, the crust of the Moon. in outer space, as seen in the Nova Scotia fractal below and as discussed. This may explain why the two arms of the mid-continent rift appear to have been extended in the same direction and toward the same North America refold arm, see below left. Okay, well, specifically, this is the mid-continent rift here, and there's this crescent moon shape again, and I'm highlighting it now. It extends down to the southwest like that, and it butts up against the Grenville fabric on the right, which is over here. Okay, again, there'll be much greater detail shown later, but the location of the mid-continent rift is right here. I'm highlighting in red, and it's again butts up against the Grenville fabric, and being that it's left of the center line here, as you can see back on this diagram of which I'll go back to on the right, it is somewhere in this area where I'm highlighting. See that, left of the center line? So as the arm extended, we're talking about the left arm, it is to the south and west, that extension direction. So that's what we see over here. That's what I was describing. The extension is to the south and west toward that arm that is embracing the moon's crust. Okay, back to the text box. Geologic literature says an extensional event with triple junctions in Rodinia occurred between 875 and 750 million years ago. As per this model, this extensional event was the crustal refold chain structure dislodged column of refolds from the very large planet, allowing for the locking mechanism to provide stability at each side of the chain at the poles of the Earth after attaching to the inner Earth. See other PDF regarding locking mechanisms. That's coming up soon. Geologic literature, Rodinia began to break up 800 to 750 million years ago. This was the Canadian impact on Earth, as per this model, that resulted in global cooling, yet another snowball Earth, after approximately 720 million years ago, as per geologic literature. Again, there's that little bit of lag time, but there it is again, snowball Earth. As per geologic literature and this model, Rodinia rotated into lower latitudes between 800 and 750 million years ago. This rotation was the breakup of the locking mechanism on Earth at the poles. See other PDF for more details. It's coming up soon. Okay, just for further clarification, this slide shows the unraveled version of Rodinia here, missing the top here. It's this structure missing the top, which was unstable, did not make it to the Earth. So what we see is like the lower 2/3 or so. And see these legs here, they've anchored down to the inner Earth. They're really representing the Southeast Asia refold. So I'll draw it in like this. Okay. So what you see here is the mid-continent rift, which is called the MCR. And this is from a published mapping of it. It goes from Lake Superior area up here in the north, all the way down to like Alabama and all in the south. But I'm just tracing it out. It extends to the southwest like that. And it's disjointed a little bit. It extends to the southwest on both sides. And you have the Grenville fabric here that it's butted up against, which formed first. And then it pushed into it later, as we'll discuss. So as I say here, the mid-continent rift, its formation is likely related to arching, refolding, and the Grenville orogeny dynamics. So it all formed as part of that whole refolding event, and there was arching and all that. See, whether it's plan view or profile view, there's this arching to make this long axis steepen up and all. And that formed from basically, you have this Grenville associated fabric in green, and the arrow is shown where there's an approximate impact location over here. So what I'm going to do is highlight where you see this perpendicular element of the Grenville associated fabric here that goes in this orientation. So we got it here. It's one location. Kind of feeds in. You could say 2 here or whatever. Got 3. You got 4, you got 5, and maybe 6 here. Definitely one here, 7. And where it's not in that perpendicular orientation, it goes along the path of least resistance, which is, as I'm highlighting here, up in North America, for instance, where everything's crescent moon shaped, and path of least resistance is probably right along the fabric. So you're getting it right on the borders and stuff, and border of Northwest Africa here, and border of South America here. Okay. So Grenville orogeny, 1.3 to 1.09 billion years ago. It actually includes part of the extension period. I guess it overlaps it or whatever. The MCR formed at the very end of it, 1.1 billion years ago or so, 1.16 to 1.09. I'm guessing closer to 1.1. Okay, this is very, very critical slide here. This kind of proves all this seemingly bizarre stuff I've been talking about. So listen carefully, check out this PDF, blow it up, look at it really carefully on your own time. So this is really, really cool stuff. This is a fractal on the left side where I'm checking the lower left. I'm not going to talk about the upper left fractal for now. There's several fractals there. So this lower left fractal it's in Minnesota, and it's the Mid-Continent Rift. I call the MCR. And there's a published map of it here on the right that I'm circling. And this thing extends all the way from like Lake Superior in the north to like Alabama in the south. And they keep discovering, recently they've extended further to the south, these arms, or maybe one of the arms, whatever it is. And wouldn't be surprised if they discover more at one point, because of what I'm going to talk about, the different phases that it went through. Now, while I'm talking about these phases, which I discussed, they're shown there on the left, from the red to the blue to the white. So it looks like the later phases, the blue and the white, are shown in this published map here on the right. It's like a combination of the two. Okay, I'm going to read the text boxes and describe in more detail with some highlights and things. So first one over here, the Mid-Continent Rift is approximately 1.16 to 1.09 billion years old. It originated on the Very Large Planet and later deformed during the various events as described herein. So keep in mind it's a refold. Okay, it was formed on a refold, and it is a refold, which basically formed by arching, extension and arching. And you could say compression too, but it's the main regime is tension and arching. Okay, I'm going to read this illegible text box here. Mid-continent rift formation and deformation. 1. Formation by refolding on the large planet 1.1 billion years ago. 2. Extension to the southwest towards the closest arm of the North American refold arm just after 1.1 billion years ago to embrace what may have been the moon's crust, this outer space event. Okay, let me talk about that. So let me introduce this location where the MCR is. Look at the upper right diagram I made. I'm going to highlight where the MCR is. Okay, it's over here. It's left of the center line of the axis when these continents were all together on Rodinia. The asteroid hit, which you see in the lower right inset. See the asteroid that I'm highlighting. So that hit to the north and east of the MCR. And everything rotated counterclockwise because that asteroid hit left of the center line. If you see the blue center line arrow in the lower right diagram. So it hit to the left of it and things started rotating counterclockwise. So the significance of that force, the momentum of the asteroid, which is to the north and east, and again it goes to the southwest, and it's above the MCR. The significance of that I'll talk about in one of the next phases. But prior to the asteroid impact, the things I was just talking about in the text box when I said formation by refolding on the large planet 1.1 billion years ago, and especially here the extension to the southwest toward the closest arm of the North America refold just after 1.1 billion years ago to embrace what may have been the moon's crust, outer space event that I was talking about. So what's going on with that is the location on Rodinia, where the MCR is, when it looks like Rodinia here. I'm looking at the upper right diagram. So there's Rodinia. Again, it didn't have the top cone. Oh, yes, it did at the time. When it landed on Earth, it didn't have the top cone. But the location of the MCR was about here where I'm highlighting. It's within the left leg, and it's influenced by the extension of that leg. So both legs extended around the refold structure of the moon, which it embraced. So as it embraced it, there was extension in that direction. That direction is, if you look at the main fractal diagram on the left, that direction of extension is this way. And that's for both legs. So I'm drawing two arrows in here. So the way this fractal is drawn, and I drew it very, very carefully. I drew what I can see basically, but you can see there's like pieces connected by string. So there's an indication that there was extension. And that extension, you can just see it really. It was to the south and west, and you had a Boudin here to kind of prove that. That Boudin formed originally in an extension direction to the south and west. So that's that stretching of the arm. The stretching of the arm of Rodinia that I'm drawing the arrow to here as it embraced the moon. Remember that fractal I kept showing with showing Rodinia in red, and it's embracing the moon and letting it go. So as it embraced it, it extended. So the red in the main featured fractal here on the left in Minnesota, you can tell there's extension, like I said. It went down to the south and west. And then we get to the third part. Release of the moon's crust and springback and compression to the northeast and north, as seen in the slack in two locations of the red refold, kinking, minor compression, folding in at least two, I see three locations, on the right side of the red refold, and general shrinkage of the red refold sections. Okay, so if you look at this diagram, you see there's a big kink over here that I'm circling. If you look at this fractal, I should say. And there's another kink over here, and there's another tiny kink over there. They get smaller as you go to the north. So there was a compression direction, I'm going to put it in the text box, to the north. And there was also a release to the northeast. So as that leg snapped back, it compressed in the northeast direction. And as you'll see on some fractals later, there's actually a northern component, and that's exemplified here in that kinking direction, which is from most to less to least in the north direction. So that's why you develop that slack and the kinks in the red section, that red phase. You can see those pieces of the red fractal actually, like, connected by the red line or string, I call it. You can see slack in the string, which I'm highlighting on the left side over here. See that slack? And there's pretty much slack, everywhere. The fact that there's string that's a little bit non-stretched. I'm highlighting another one, for example. Okay, next phase, reading from the text box. 4. Global extension to form the locking mechanisms, 875 to 750 million years ago. This event is not evident in this location, matching geologic literature. So yeah, according to geologic literature, there wasn't extension at that time. And it's not shown in this fractal, this main featured fractal, because it only shows, we could have a re-extension, but it only shows the resting position after it snapped back. So that's what's going on in the from the red to the blue is the snapback. So let me read what the next step is. 5. Release of the locking mechanism, producing west to east snapback, sweeping counterclockwise rotation, and general shrinkage as observed between the red and blue refolds after the asteroid impact 750 to 800 million years ago. So I drew in the blue arrows from like piece to piece between the red phase and the blue phase, and you can see pretty detailed what's going on. There's that sweeping, it's getting butted up against the Grenville front, which is like a physical front of some sort. You can see on the published, I'm circling it now on the published map here. So you can see some cool stuff in a sec. Okay, next step, 6. Rapid counterclockwise rotation as observed from the blue refold to the white refold. The source is from the northeast heading to the southwest after the Canadian asteroid impact momentum arrived at 750 to 800 million years ago. The MCR appears to have rotated counterclockwise into the Grenville front after the Grenville front formed. So you'll see it kind of tripping over it. Check this out. Okay, I'm going to put in red highlighter. There's this piece here that I'm circling in the blue section. So that's in plan view, and you actually see like a profile view of it after it rolled over the front. Pretty cool stuff. And you can see the top head of which is shown in white. That's affected more because it's closer to the source, and that freight train, that momentum from the asteroid impact is going this way. I'm drawing a red arrow. So it kind of pulls that head. And you could actually see a lineation here. I'm highlighting inside the red circle here. There's a lineation, this violent counterclockwise lineation there. And also, if you look at the Boudin down below, putting a check mark there, you see that white arrow. I know there's that sweeping and that rotation because if you look at this part of the Boudin, there's like a indication of a headwind in that direction. All right, and only the top section rotated because it really butted up against, the blue is already butted up against the front, and it just kind of rolls over where it is able to in this section that I showed. We're putting a check now. So you can actually see the two phases. If you look at the published diagram here, where I'm highlighting in red, this is like the white phase. And you can even see this here that I'm highlighting. That's part of the white. And the blue, I'll put it in another color. The blue is over here. See that? So now this stuff is really, really coming together. I mean, this is the nitty-gritty kind of thing that shows the validity of the model. And as we go along in these presentations in advance, you're going to see that I know that I was right, but you're going to see. Okay, there's a new fractal here, but let me do a quick review here. Reading the text box. Fractals, Rodinia, the original Precambrian crust of the Earth, was a section of a chain of refolds consisting of 7 interference refolds that was likely ejected off a large celestial body or planet just after an asteroid or planetary impact at approximately 1.3 billion years ago. It is estimated that Rodinia was actually ejected off the planet at approximately 1.1 billion years ago. So there was that arching and all, that original formation of the MCR, and finally it was released sometime around 1.1 billion years ago. And then I talked about that extension, Rodinia, the arms of Rodinia extended around what is the moon. And that's shown in this fractal in the middle here. So you have Rodinia in red, and this is about 900 million years ago. So it was ejected off the large planet about 1.1 billion years ago. And then, assuming pretty quickly, it got to orbit around the inner Earth, which is shown in blue here that I'm highlighting. Okay, and it must have orbited something on the order of 200 million years, because this is an event here that is showing, first of all, the Rodinia structure here where I'm checking, that's with the arms down, and then this high energy event, which is what fractals shows the arms going up and releasing the moon. You could actually see flat parts of the moon here where I'm highlighting, and both sides. That's evidence that it was being squished by the arms of the Rodinia refold structure. You got a double refold structure here that's stabilized by the embracing of by the arms of Rodinia around what became the moon. And there's actually an orbit direction that's evident from these en echelon structures in red that are below, and the movement is to the right. And another thing to note, you notice the right arm where I'm checking here, highlighting. This right arm was longer, apparently, at least at the end or whatever it was, than the left arm. So the reason for that is if that orbit direction is to the right, it's going to provide more protection by leading the way with that longer embracing on the right side. It sort of provides more protection and stability. So when it finally releases, it starts sticking, as you can see where I'm highlighting in this upper section, and it finally ends up releasing the moon and going into a journey to reach the inner Earth. So another thing you'll notice, if you look at the centerline axis of the double structure here, I'm highlighting in red now, it goes up and it starts to bend in the direction of that equatorial spin axis, which is in green, and that's shown in this fractal to the right. But the fractal to the right that I just checked, that is younger than the one that I'm talking about now, and that's the general direction of time sequence, like I said, is counterclockwise. So this thing starts here, just say where I'm putting the red, and then it goes to the north and the west, and it gets younger and younger this way. And this fractal right here that I put the red ellipse around, that's another one. So you got 1, 2, 3, and this one is 1, this one is 2, and that one is 3. So that's your time sequence. And what I'd like to get into now is the details on this one on the upper, in the right side here. So this one on the right, it's after a high energy event, and that high energy event is the asteroid impact in Canada. So I labeled these refold structures. These are the subdivided refold structures that when Rodinia landed on the inner Earth and probably initiated the spin direction to the east, as you can see with the equatorial spin axis shown in green, the refold structures stabilized, and then they eventually broke up from that asteroid impact. And there's a big action here. You can see the blue line, which is the center line of the refold chain. It became all disrupted and everything, and I'll get into more detail later about that. But if you see, I labeled the refold structures, which are the continents or land masses. There's 7 of them. I talked about that before. Number 1 is Southeast Asia refold. Number 2 is the Russia refold. Number 3 is the North America refold. Number 4 is Africa refold. Number 5 is South America refold. Number 6 is a combined Antarctica, Australia, and India refold. And number 7 is Continent A, which later disappeared into the inner Earth, as I talk about later. So because that asteroid hit left of the center line, you see that blue, if you look at that blue axis that's bent, it moved in a counterclockwise direction, and that asteroid impact is shown there, so it bent everything to the left. And there was this counterclockwise rotation, as you can see from the arrows. So what happened with the Southeast Asia refold, which is like a stabilizing refold, which I'll talk about more later, it's number 1 there. See, this one, the legs were yanked out. They were attached to the inner Earth, and that was attached to the inner Earth to the below the equatorial spin axis in green, and that's sort of stabilized the chain structure. And like I said, I'll talk about more in detail how the Southeast Asia refold kind of regulates lateral and longitudinal movements to reach equilibrium about that equatorial spin axis. But what happened here, there's these yellow en echelon structures that are a little hard to see, but they're over here where I'm circling. So that indicates that the legs were yanked out suddenly, and you can see them curl up in the Southeast Asia refold, and you can see that violent action of the Russia refold in number 2. So that those en echelon structures indicate that shear movement direction, that sudden movement that is shown in the fractal. So that equatorial spin axis, you could actually see the trend of that 900 million year old fractal below. It starts to approach the one that I'm talking about now in the upper right. So I'm highlighting now. You see this, that equatorial spin axis direction is matched as the axis of this guy, the 900 million year old fractal, which is number 1 here. I call it. It goes to number 2. It's almost as though the fractals are trying to show us something here. So you want to go from 1 to 2. I'm going to show you that you're related here. And I'm going to show you that center line, that equatorial spin axis, and it's going to just like meet up with it like that. So just something pretty cool to note here. The Earth's, look at the text box on the left, the Earth's inner core formed 1.1 to 1.3 billion years ago, according to geologic literature. So that kind of gives validity to the whole space event kind of thing. Okay, see this text box at the lower right. The cycle of 7 refolds on a chain repeats 3 times about the equatorial spin axis in green. So what's shown on the fractal is like right after, during and after high energy events. So what's going on is this is going around the Earth, and it's sort of defined by these time sequence events, and time advances this way where I'm showing the arrow now. So for one fractal, it goes this way. Don't get confused. But for like general time sequences, it goes in a counterclockwise direction. I've seen that a bunch of times, from 1 to 2 to 3 counterclockwise. Okay, just another slide showing this 900 million year old event in the center. You can see I'm highlighting now this orbit direction with the blue arrow based on these in echelon structures. More complete diagram is shown here. And again, what I just talked about with the double structure, double chain refold structure attached here, and then later the arms going up here and releasing the moon. And then in yellow here, this fractal, this is all in, this one's in Minnesota also. The center one's in Nova Scotia, and both of the ones on the right are Nova Scotia. This Minnesota fractal in yellow, just after the release of the moon, the sudden upward compressional direction, and after it starts its journey towards the inner Earth in blue. Incidentally, there's a mid-continent rift fractal in the magenta color, and all the features are shown just as I described. This is just showing the center line of it. This is a different fractal than the one I showed. But you could see the different segments of that MCR. You could see the kinked area here and here. Oh, well, really, and here. Depends on how you look at it. There's like 2 or 3 kinks. And you can see the from the snapback, I'm drawing an arrow here. After this snapback below, things drifted up to the, so MCR is over here, so things drifted up that way because it's associated with this arm here on the one side. So you can see that it moved to the north and east, and you can see remnants of it when it was stretched to the south and west here by that segment, and of course this segment, so everything extends to the south and west because that arm was embracing the moon to the south and west here. Again, we'll have to get in more detail later, but if you look at the upper right portion of this slide, you can see there's a more complete fractal showing a couple of different events going on. Basically from 670 million years ago to 550 million years ago, after the Canadian impact, which was at about 800 to 750 million years ago. Okay, this slide shows basically 6 phases of Rodinia. If you look at the numbers, when you Start on the lower right, get number 1 here. We talked about this. Number 2. Now, number 3 happened just before number 4. So based on the dynamic, you can see, okay, based on the arm here on the right, I'm circling, and on the left, that this was just before number 4, because as that quick snapback up, in this direction, I'm making arrows here, that snapback direction, there's internal compressional features here in the dashed yellow lines. So this was like so sudden, I drew the axis in the blue, the axis like centerline axis, that it actually, compressed pretty good, like it shows, and it actually made like a distinct centerline feature there where it's more pointed versus this one where it's flatter. And you notice that axis kind of goes in towards the viewer, like it's more rounded on number 4. So it's like blowing out in the direction of the person viewing. So you have like a flatter arrow here on number 3, and then it blows out in number 4, and it relaxes a bit in regards to the pointed section that I pointed out in the number 3. So this is flatter here, as I'm showing in number 4. And then the legs go down and relax, and it goes off, like I said, starts its journey in number 5. All right, and I think that if you look at number 5, I think this top hat above here, I think this section was lost at one point, because in number 6, it appears to be gone. I mean, it could be the angle of the fractal, but based on careful analysis, it looks like it broke just where I showed you. Based on the general features, I mean, you could even see, look at number 5, you can see a dent there, and here's that dent again. Then it curves up, and I think that, yeah, it just looks like it broke at as you can see in number 5, it broke on that upper dashed line. So you're going to see these dashed lines again on other fractals. Okay, here we have a slide showing form and function of these Refold fractals, and some representing probably Rodinia, if not all of them. Okay, I mean, and the MCR, for example, is not Rodinia, but it mirrors Rodinia. So I actually showed a picture of this thing that you find like at amusement parks and all, and that's one of those claw crane machines, it's called. So you notice the shape of it, and then you notice the shape of all these fractals, very similar. There's the bell-shaped thing going on, and I put some of those I put in blue, as you can see down here with this fractal we keep discussing from Nova Scotia. You see the bell-shaped, clamp-shaped structure there. Okay, so you could also notice there's a notch on some of these. I'm circling one of the notches now, and there's another. So that notch was formed, as you see in the Nova Scotia fractal. There's that notch there from that action where the two structures were kind of glued to each other, and they're sticking together and all, and it finally the moon got released and all. But there was some apparently somewhat permanent kind of result here. Okay, these fractals that are shown in North America and the United States. They show Rodinia and basically different phases of Rodinia. You've seen these here that I'm circling, and this one also. And this will be discussed more later than I'm circling now. That's Rodinia. You can see that weak spot there. I didn't find that there might be a second weak spot here, but basically I drew the line in where you can see you can actually see the line in where I drew any of these lines on all these fractals. You can actually see that, in the fractal. It's not like I'm just deciding to draw these lines in. You can see that in the fractal. But it's just an example of showing a bunch of them together. I'm saying compare these fractals of early Rodinia. So all this is outer space refold chain fractals about 900 million years ago, just to remind everybody where we are. And this one in particular in white is very good. You can see I put in the lines for the 2 weak spots, and saying Rodinia in white, the top of the cone was later lost. The Russia refold border is likely the green line. Okay, the top of the Russia refold is likely this line, so that's what I said before. The second weak spot is, or the upper part above that was lost. The cone was lost. But what I'll get into more in detail in a little bit is this Southeast Asia refold, which is shown here. I'm circling it as part of that fractal that I showed recently. That was after the impact. I'm claiming, and I'll get into more detail later, that the 2 arms were sutured to the inner Earth, the center of the inner Earth, the core, and that asteroid impact yanked them out basically. So you could see that reaction with these legs have sprung back and coiled in. So I'm highlighting that now. And in this fractal, excuse me, in the white of Rodinia, you can see like different phases of action. You got the white outline, and then to the red, see the where I'm circling now, and then to the blue. And there's even like a you could actually see like the outline of Southeast Asia. There's like this tectonic mimicking here, and the yellow line, it even shows like a bulge in the middle. And note the similarities between really these different phases and this fractal here. I'm drawing the arrow down below with the one I just talked about showing Southeast Asia refold. So there's interesting similarities here. Okay, the next few slides are the Theia impact about 900 million years ago. This is when Rodinia lands on the inner Earth. And when Rodinia lands on the inner Earth, you have the initiation of the equatorial spin axis on Earth, still spinning to the east. I'm also going to discuss the role of Southeast Asia refold in maintaining equilibrium about the equatorial spin axis. Okay, so what we see here is the complete fractal to the north of the structure that's always referenced, the double chain structure. And after the moon was released by Rodinia in orbit around the inner Earth, the Rodinia eventually reached inner Earth. And I'm going to discuss, when it landed on the inner Earth, what it did, it probably initiated a spin direction. I say here the spin direction of the refold chain, which is Rodinia. It's a chain subdivided into 7 refolds. It was along the equatorial spin axis. And this happened because most likely the Southeast Asia refold landed first, and the rotation was completed as the Russia refold landed, and it ended up, of course, adjacent to the Southeast Asia refold. And that completed a full cycle of rotation at the contact of the Russia and Southeast Asia refolds. Okay, so with this slide that shows the entire fractal, the sequence of time is from the northeast to the southwest, as I'm drawing an arrow here. And again, the fractals show very high energy events, so that's what's recorded here in this advance of time. There's actually 3 cycles around the Earth. There's 21 refolds, or 7 of them repeated 3 times. And as you remember, this is the Southeast Asia refold here. And here it is again. It pulled the Russia refold back, trying to maintain equilibrium about the equatorial spin axis. After being yanked out, both legs yanked out, one leg went back in. It pulled the Russia refold back. And over here, there's a third time it comes up. It looks like it's off the center of the equatorial spin axis, but it's really connected below at the inner Earth, right at the equatorial spin axis. And you see the lateral and longitudinal oscillations in sort of a train dynamic that is basically regulated, controlled by the Southeast Asia refold. And incidentally, I just noted this fractal may demonstrate the existence of the supercontinent Pannotia 633 to 573 million years ago. Now, I claim that this fractal is basically 670 to 550 million years ago, showing the movement it shows after that impact. The impact was like earlier, 750 to 800, but everything's in a time warp. And so Pannotia is basically defined as when there was a lot of land concentrated at the poles, which implies significant lateral movement in this model. And there was just connected by a thin strip of land at lower latitudes. So you could see this gives insight to that because there's a lot of action in the lateral direction. And eventually, as I said, it's restabilizing laterally and longitudinally. Apparently at the end, there's actually some compression at the end, at the south end of this, the southwest end, as I'm circling. But again, more details later. But basically, it appears that that Theia impact has initiated the direction of the spinning of the Earth to the east along the equatorial spin axis. So this is basically the driving mechanism of tectonics, the early driving mechanism, where things are trying to, Southeast Asia refolds trying to maintain equilibrium about that equatorial spin axis. Okay, I'd like to clarify that we're still basically in the chronology of events, we're still basically at 900 million years ago. I've jumped ahead a bunch just because it's necessary. It's really almost impossible not to, just to show the concepts. I got to jump ahead and back. But anyway, we're at about 900 million years ago. And here again is that outer space event showing Rodinia and releasing the moon to refold structure, chain refold structures subdivided. We discussed this many times. And as you can see in this lower left diagram, this magenta axis for both structures is starting to go in a certain direction here, as I'm highlighting. And that direction is the same as the equatorial spin axis in the fractal to the north, as I discussed previously. I'm highlighting now. And one thing I noticed is very interesting is all these fractals, they advance in time in a counterclockwise direction. Always see that. So the fractal to the north, it's advancing in time in a counterclockwise direction. I know it's to the north, but the next one is to the north and west. So there's this counterclockwise motion. I see that a lot. I have to explain that at this point. Another thing that I have to explain is a lot of these fractal images are like mirror images of what is actually going on. It took a lot of time to notice that exactly what's going on, and that happens a lot too. In this upper right diagram, shows the Russia refold here below, shows its subdivisions and everything. There's a whole dynamic there. No need to get into detail at this point, but the actual image in the fractal was reversed, so I had to do like a mirror flip of what it is. And that happens in this fractal to the north, as I was talking about, that shows the phases. I'm circling now. It just shows the bottom of it there, and it's also shown here where I'm circling. But there was a lot of like flipped imagery, and worked out beautifully when I flipped it, when I corrected it. And anyway, in this fractal to the north, I'm putting a check now on a section of it. What's evident is that in order to maintain equilibrium of like lateral and longitudinal movements of these seven subdivided, these seven refold structures, which are the land masses or later, basically the continents on Earth, this Southeast Asia refold, as I'm highlighting in the middle drawing here, the Southeast Asia refold is always locked in, always attached to the equatorial spin axis. And it seems to be like the captain of the ship in sort of guiding tectonics to reach this equilibrium. In fact, to very briefly discuss this fractal on the upper right, this arm here of Southeast Asia, it pulled in the Russia refold, which is below right here, pulled it back to the equatorial spin axis as a method of maintaining equilibrium and stability. So as the captain of the ship, as you can see, is always it's the refold that is guiding everything. And in the middle diagram, it was temporarily destabilized. The whole chain was. And the two legs of the Southeast Asia refold were yanked out. They were attached to the inner Earth. And you can see that I'm highlighting now that arms have been pulled out. And even these en echelon structures here in yellow, they indicate that move, that basically that action that the legs were yanked out from the inner Earth. And the blue line here that I'm highlighting, that's the basic center line of the chain that got disrupted from the even straight line of the equatorial spin axis. And you can see, we'll get into more later about this locking mechanism, but you can see that it looks like the locking mechanism was busted up because you can see the curls of the ends here that I'm circling. The ends of the refolds are curled in like they just got snapped out. But back to the Southeast Asia refold being the captain of the ship. In the middle section of the refold to the north that I was talking about, which is right here, I'm highlighting, putting an arrow in. The Southeast Asia refold is right here. And there's some forces that are trying to pull it off that equatorial spin axis, but it remained on there because one leg has, as you can see above, one leg has reattached here, and one leg was used to pull the Southeast Asia refold back. And it never went, this arm that I'm highlighting never went back. It just remained to today, not sutured down, unlike the other leg to the right here. That's still sutured down to the inner Earth. And the bottom diagram, we'll get into more detail later, but this is the breakup of Pangaea. And it shows an example of what I'm circling here. Southeast Asia refold is shown as such where I'm highlighting, but I had to reverse it as such to reality. Okay, the next several slides involve the formation of the locking mechanisms of Rodinia at the north and south poles of the Earth from about 875 to 800 or 750 million years ago. Okay, this slide describes, gets more into this locking mechanism. So after the Theia impact on Rodinia collided into the inner Earth and initiated the spin axis to the east, based on the way it landed and the momentum and everything, there was global extension between 875, 870, according to literature, to 800, 750 million years ago. And according to this model, that's the formation of the locking mechanisms at the poles. Okay. The geologic literature model below that I'm circling shows that there is only certain zones that underwent extension. But in fact, as I discussed previously, the MCR, which was in Laurentia, which I'm circling here, that did not undergo any extension during this time, but many areas did, as seen in the blue lines right here. So what is this locking mechanism? Well, it's the only way I found out from doing my project, the initial presentation, as I was physically trying to show the globes, the first globe of the early Earth, which is right here circling. I noticed that the only way to fit it on is to, show it as such. And it turns out that's this this way of the Earth's refolds stabilizing. And as I discussed previously, there's evidence of that, of the breakup of this locking mechanism in this fractal. So I'll actually show some fractals soon about showing the development of the locking mechanism. Okay, this slide here shows that same fractal on the right side in Nova Scotia. I say about 670 million years ago was the beginning of the fractal at the northeast end, where the Southeast Asia refold is here that I'm highlighting. Again, the asteroid struck, and there's even a fractal of the asteroid. It struck and bent the centerline axis as shown in blue, and originally it was at the equatorial spin axis. Everything was stabilized by this locking mechanism, and the locking mechanism was broken up by the asteroid impact, as I'm circling evidence of that locking mechanism as these curled zones here on each end of the refold structures. And there's more further down. I'm just showing an example of this. And by the way, it looks like the Russia refold really got thrown here because it's at the top of the maximum movement here, and it's a little bit like smaller or whatever. It was riding not very stable on the back of North America. So you can see that it really got, thrown over here. And what happened is, even in geologic history, it says that rifting first started occurring about 670 million years ago, which is what I called this refold age at the top end, at the northeast end. So as you see the clay diagram from my first presentation, this is like bigger, and it happened quicker on the proto-Atlantic side. And matching the 670 million years ago or so that rifting was noted. And then later it happened on the Proto-Pacific side too. So just to repeat, the locking mechanisms existed basically 875 to until the asteroid impact, which is I'm estimating 800 to 750 million years ago. So just something to note here, if you look at the character of the estimated, at least, locking mechanism here from my initial project, initial presentation, showing the spin axis direction in the red arrow here that I'm now highlighting. So it only makes sense actually that the locking mechanism would be oriented as such, because it's a more stable orientation that it's curled as such this way with the spin going as shown, than if it were curled the other way. It's sort of a stabilizing kind of structure if you think about it, if you visualize it. So it's spinning counterclockwise here in this diagram, and with the way the curling is, it's just sort of, it's a stabilizing type of thing, as opposed to if it were the other way. So just kind of imagine that. Okay, these next few slides are actual the globe of the early Earth, and it's just after this first one is just after the Theia impact, which is when Rodinia landed on the inner Earth, and its 7 subdivisions or landmasses basically lined up with the spin axis, because the spin direction was initiated by the momentum of the movement when it landed on the inner Earth. Probably landed with Southeast Asia first, then Continent A, then this refold with Antarctica and Australia, then South America, then Africa, then North America, then Russia. By the way, North America and Russia are probably, they're around the corner, so you can't see them. So this fractal is in Northwest Australia. And if I were to put Northwest Australia here, it'd be about right here, which is kind of maybe not so coincidentally the center of mass. And this is the first of the fractals. The next ones are going to advance in time in a counterclockwise direction. which I said before is very common. You see that a lot. A couple of things to note. I drew the fractal out in the ocean because I saw basically a lineation out there, and it wasn't a mistake because this thing is comes up in a similar, this globe comes up in a similar shape on the next one. And you'll notice the South Pole here is quite flat, and as opposed to the North Pole area, which is near this bulging end. You also notice that some of the shapes, inherited shapes, have been around forever. I mean, look at Antarctica, which I'm circling here, and even on the insert, same basic shape, circling this now. So you also are going to notice, I don't have time to point everything out, but notice the changes from one refold to another. If you look at Africa right now, it's doesn't have a very thin edge around the locking mechanism. It's just sort of functioning to stabilize the other ones. And you'll notice Southeast Asia, which looks like its southern border is not shown. It's like around the corner or whatever. But right now the arms are up as I'm drawing the arrow here. And that's going to change later. You're also probably wondering, what the heck are these things here that I'm circling? They look just like Rodinia. Well, they are. They're related. I was saying all along that when Rodinia got launched off the large planet, it was shaped with the cone, just like I'm circling on this one, for example. It had a cone and two legs and everything. And there was probably a lot of these things because it was in a big area with tons of them. They probably dissipate to like nothing on the edges of the zone, of the deformation zone, but probably a bunch of them went out into space. And I think what these guys are trying to show, in fact, one of them, as it gets away from the zone, is sort of going another direction. But as they're getting close to the zone of the globe, they're all heading somewhere. See these two? And they're all pointing somewhere. They're all going to the back, which is apparently these things, based on my experience, they look like they're heat seekers. So there's a lot of heat in the back. Probably the inner Earth is still exposed. You also notice one of these, again, I use a shoreline to show the fractal here. I'm circling this one guy here. See that? Basically defined by the shoreline. Okay, this is the next phase of the development of the locking mechanism, showing sort of what's supposed to be the globe, but it could be some destabilization existing. The first fractal is over here. Just put a check where it was, and this one's over here. So these, they're going to advance this way, and then this way, and that way. So I believe it's counterclockwise direction, basically. So again, this is in Australia, Northwest Australia, and this is the second phase, like I said. So what you notice here is the Southeast Asia refold here, which I just highlighted. It's showing in white as just internal deformation. There's a line there that I just decided to highlight just to kind of show there's some compression there. So what it is doing is, I'm putting a circle here, the right arm is trying to anchor down to the center of the Earth at this point. And the adjacent refolds, which are continent A above and Russia below, they kind of mimic what the Southeast Asia arm is doing. So time is advancing down like this, and basically it looks like there's deformation in this direction. As you can see, everything kind of sprung up and is distorted. I have the refolds labeled, North America, Africa, South America, and all that labeled. So everything's kind of pushed up in that direction as this first arm tries to suture down to the Earth. And it looks like, over time, as like I said, as time goes this way, the Russia refold reacted, and it's kind of shown off the globe, but regardless, there it is. And then it shows two phases. A lot of times you see like little phases with these fractals. So eventually it well, it likely got pushed up, I should say, right here on the left side from North America, pushing it up. Now, it's a little deceptive here because it doesn't show all of North America, I believe, but I believe that also pushed up on the one end, and it resulted down here where I'm showing the Russia refold got pushed up. And of course, the adjacent refolds follow suit. Continent A right here with the yellow, and the Russia refold with the red here. You know, they mimic the action of the Southeast Asia arm. So eventually, as things started to stabilize, the Russia refold went down to the yellow, and it's showing the second phase of it just below. I'm highlighting it now. So it eventually joined up with North America below. I believe that's North America. So again, these are shown off the main globe, but you know, these fractals have a mind of their own. It's kind of strange. Okay, this is the third phase of the globe of the early Earth, development of the locking mechanism. This is in Australia. And again, time advances in this direction, and then it actually goes up back to the top again. Okay, this is you know, it's a globe, so makes sense. All right, based on the previous fractal, the mimicking of the Southeast Asia South Pole arm that you saw was taking place at the Continent A refold and the Russia refold, which were adjacent to it on each side. So in this case, you can see this red arm here is still up, but it's not up as high as it was. It's actually come down a little this way. So as that Southeast Asia arm sutures down, that right arm sutures down to the inner Earth, this Continent A refold will look like this. And actually, the left arm at the North Pole of the Southeast Asia refold is also going to follow suit. It's going to attach to the inner Earth. How do I know that? Well, that's what's going on here. This is digging down to the inner Earth like that. Okay. And this second instance, a later instance of Continent A here, looks as it does because once the arm comes down on the right side of Continent A, then it's finally going to go rebound like this, sort of a delayed reaction, like as these arms come down on the adjacent Southeast Asia refold, which are on this side of it too. So it's drawn as shown. So it's going to be like a rebound, almost like a snapback kind of thing, just like that. So now the Southeast Asia arms are sutured down to the inner Earth, and you can see the development of the locking mechanism here. And Southeast Asia refold is really not involved in the locking mechanism anymore. It plays a part in it. The thing's trying to find the most stable configuration to stabilize the whole structure. But that's what we have at this point. Something to notice here. It looks like, you see the Russia refold here, this arm. Looks like that, based on the tugging of the above Southeast Asia refold, as it sutures down to the inner Earth, it looks like it pulls off the locking mechanism temporarily over here on the South Pole side. Okay, this is the fourth globe of the early Earth, showing Rodinia. It's with its subdivisions. In this case, it looks like Continent A is around the corner, not shown. That's the only one missing out of the 7. We got 6 here. 1, 2, 3, 4, 5, 6. Yes, can't see the bottom border of the Antarctica and Australia refold, but that's fine. So you can see at the North Pole, there's quite a stabilized, more stabilized looking locking mechanism. South Pole, same thing. And you'll see that See now this Russia refold has restabilized to the locking mechanism here as opposed to the previous slide. Just a little thing to note, the initial shape of the top border of Russia refold is like this, and it later became this, which is kind of mimicked below. That's why I know it became later, because time advances this way. You'll notice that you see it's very subtle, but you see that little dent on Antarctica, which is evident over here on the insert. You know, that's that characteristic inherited shape of Antarctica that you see up till today. Okay, on this slide, you see the chronological order that we just discussed, 1, 2, 3, and 4, showing the inner Earth. And I had to, in previous slides, I had to go forward in time a bit to kind of describe concepts that are very critical and make it more understandable. So there's that forward back kind of thing. But here we are. We just talked about the development of the Earth's locking mechanism on each pole. And as we move forward, you're going to notice that the most mobile or unstable refold structures, or continents, whatever you want to call it, land masses, out of the 7, I would say the most stable is going to be Africa and South America, because it looks like they're sort of united already. Like they're, it's almost like South America is a subdivision of Africa. You can see that a lot because it almost looks like an internal deformation at their border. So the more unstable ones are adjacent to Southeast Asia. You can see continent A, and you can see Russia on each side. They're going to be the more mobile ones, as you'll see in the future. So that's just something to keep in mind going forward. Okay, this slide is it's already been shown, but we didn't see these guys on the right. These heat seekers. So, do you see how, remember there was a little bit of an issue on the right side with the Russia refold on a previous slide, was temporarily pulled away from the locking mechanism and then it restabilized later. Well, even if you look at the right arm of the Southeast Asia refold here's Southeast Asia. So the right arm, I'm not going to muddy this up with highlighting it, but I'll just do this anyway. So if you go down, you follow that right arm, it's not totally on the locking mechanism, which is over in this way. So I think there's some definite heat there. And again, these fractals are like heat seekers. And there is, in fact, some kind of anomaly in Antarctica, gravity anomaly. So it's probably all related. And take a look at these fractals. They're really diving into the spot over here. It's really interesting. You got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 or so that are like really following a path into the heat zone. And these guys here are kind of veering away because they're not really close enough or whatever it is. Okay, this slide, which is the first phase of, but after the Theia impact, first phase of the development of the locking mechanism on the early Earth. Okay, so I kept talking about this, I'm going to circle it now, this fractal in Nova Scotia, where Rodinia releases the moon, the arms go up, and it's going to go off into space and attach to the inner Earth as shown, which I'm highlighting now. That's the inner Earth. So the inner Earth, I blew it up and showed it here. I only pulled it, I distorted it a little bit from what it was shown. Just remember that there's probably initial distortion as it is, but the basic shape mimics this first fractal to the left right here. See, even the flat end at the South Pole is the same. Basic shape is exactly the same. Check it out. So there's like consistency with the fractals here, and there's that just gives credence to what's going on here, what the fractals are sort of trying to show, so to speak. The next several slides involve the Canadian asteroid impact, which occurred about 800 or 750 million years ago. And with that asteroid impact, there was the initiation of the breakup of Rodinia and the initiation of tectonics on Earth. Okay, this is a little bit of a review, but just moving right along. And we're basically, although we've gone forward and back, we're now after the locking mechanism formation, and we're on to the next event. So the next event is the Canadian asteroid impact and the breakup of Rodinia. The impact was 800 to 750 million years ago, as per this model. Global cooling, snowball Earth, resulted after 720 million years ago, as per geologic literature. I'm saying from the impact. What followed the impact? As the locking mechanisms on each side became unlocked and unraveled, the primary refolds that formed the locking mechanism, North America and Africa, released tension and the Iapetus Ocean formed. According to geologic literature, this rifting occurred first in the area of the Russia refold 670 million years ago, and later to the area of the South America refold 550 million years ago. This is likely due to the nature of the locking mechanisms, see below, and refold chain dynamics, see Nova Scotia fractals, as we discussed. The chain structure was bent in a counterclockwise direction, with the impact area of the refold structures undergoing the greatest degree of chain bending and tension. The Southeast Asia refold was anchored by its two arms at great depths below onto the inner Earth at its equatorial spin axis. It became dislodged at both anchors following the impact. Eventually, one arm re-anchored and the other arm pulled the Russia refold back and stabilized the chain to some degree. This and subsequent chain dynamics are shown in detail in the Nova Scotia fractals for the period of the impact at 750 million years ago to approximately 550 million years ago. That was that large fractal that showed 3 cycles around the globe. There was 21 refold fractals, which really 7 of them repeated 3 times. Geologic literature states that Rodinia rotated into lower latitudes between 800 and 750 million years ago. Huge statement there, right here. As per this model, this is following the Canadian asteroid impact when the locking mechanisms rotated during release. Global cooling, snowball Earth, resulted after 720 million years ago, as per geologic literature. So there's those diagrams again. We already discussed this, so we're going to move on to the next. Okay, on this slide, basically I'm going to introduce the fact that there are 7 asteroid impact fractals, or maybe 6, depending on how you look at it, but there's one of them, I'm going to circle here, is the Nastapoca arc fractal that shows a pendulum-like rotation of the land, and that's basically as seen in the Nastapoca arc, which is basically the Hudson Bay and all. And below that, to the south, is a rotational signature, Great Lakes. I'll get into that in more detail later. But basically, the asteroid impact was the destabilizing thing that occurred, and the stabilizing is the Southeast Asia refold that tries to stabilize everything, as discussed before, with between the lateral movement and the longitudinal movement and all. It wanted everything, at least in the beginning, to go back to the equatorial spin axis. Okay, in this slide, this is showing the top part is a blow-up of phases of the asteroid impact fractal. And this is from that Nova Scotia fractal that has the 21 refolds on it with 3 repetitions of the 7, which is 7 times 3 is 21 of them shown. So it starts out with the yellow closest to the time of the impact, which was really 750, 800 million years ago. But I'm just estimating because it's from that fractal that I estimated is 670 to 550 million years ago. That started at 670 for the fractal at least. Then it went to the red and then to the blue at about 550 million years ago. And I'm figuring that it actually, as you see in the insert below, that it compressed a little more even, because this fractal below is about 525 to 550 million years ago. And that was around the time when the Florida Plateau was forming. You could see actually what looks like Florida in the subdivided sections. And this complete compression here that I'm showing in the insert, that actually happened after the oscillations we saw, the lateral and longitudinal oscillations in the 670 to 550 million year old fractal. So because there's like this severe time warp, there's actually this delay. And incidentally, this is later, but after this complete compression that's shown in the insert, the North American Refold went to like, it snapped back to like its normal size, and then it was allowed at that point to start rotating counterclockwise. Couldn't do it in the fully compressed state. Okay, what we see here on the upper drawing is a fractal of North America Refold. It's not delineated in this drawing as it is in another one for another discussion. This whole discussion is really about proof of the asteroid impact, and you can take a look at some of these and everything in detail. So this 33-year-old, million-year-old fractal, I know it's that age because, as you can see, I'm circling the text box now, but the Big Bend on the Rio Grande, according to geologic literature, was about 33 million years ago. So that's seen here. And the asteroid impact, which is blown up below, is shown, the location of it is shown in the yellow circle above, which I'm circling now. So we go to the bottom and look at this detail here. Now this asteroid impact fractal had already rotated counterclockwise about 90 degrees. And due to the resisting forces, it kind of smoothed out on the southeast border and on the northeast border here that I'm highlighting. And what you see here is the earlier lineations go from northwest to southeast, and the later ones are curved, and they kind of go around like an airflow kind of thing going on that go around that asteroid impact fractal, and you can see that they're curved and everything. And one thing also you notice is this Nastipoca arc fractal at the bottom that I'm circling. So that thing has rotated in a counterclockwise direction. Then I'm showing an arrow over here that's sort of like a pendulum. You'll see more detail on this later. It already rotated in that direction. That's what the Nastipoca arc is about. And incidentally, below the Nastipoca arc is the Great Lakes region, which is a rotational signature. Get into that more later. But again, this is about the asteroid impact. Okay, these slides are about the existence of the asteroid impact as shown through fractals. Asteroid impact was like 750 to 800 million years ago. And we discussed this first one here on the upper left. I should note that a lot of these fractals come together at a point. See that right here, for example. Second one, we also kind of discussed this. This is the full compression of the North America Refold, about 525 to 550 million years ago. Moving along after that, after it fully compressed, it was extended and allowed to start rotating, as you see, 500 to 475 million years ago. This whole thing's really operating in a time warp. Very interesting stuff. First was the oscillation in the latitude and longitudinal directions from the impact, and then full compression, and now the rotation in this third one here. So move right along. All three in Nova Scotia above. Now we go to Maine, USA, 105 to 110 million years ago. It's before there was any major rotation of the fractal of the land. So obviously the land was rotating, as you just saw in the upper right, but it didn't affect the rotation of the asteroid fractal until later. So that's that one. Okay, now to Nova Scotia again. And you see the same basic shape. All these have the concave up in this direction. And it's like a cashew. It's kind of curved a little bit like that. Okay, the next one we just discussed in the previous slide. And this is after it rotated about 90 degrees, as you can see, between the last one and this one. And there's a blow up of this Nastipoca arc, which I'm circling here. That's on the lower right here. You see that pendulum that had moved this way after everything had rotated, as shown in the cashew-shaped fractal above that I said rotated about 90 degrees. Okay, on this slide, I'll discuss how tectonics are the direct result of the Canadian asteroid impact. The Canadian asteroid impact was about 750 to 800 million years ago, and prior to that, about 900 million years ago, Rodinia had landed on the inner Earth and had initiated the spin direction to the east, which still exists today. And then the locking mechanisms formed at the north and south poles, so it was under equilibrium. And then suddenly this asteroid impact occurs about 750 to 800 million years ago and disrupts the chain of 7 refolds about the equatorial spin axis. The equatorial spin axis is shown in green on this fractal, this complete fractal here that I'm putting a check by. And the insert at the north end is shown on the left here. So you can see that asteroid impact, if you look at the insert, it's shown in blue, and it disrupts the chain of 7 refolds about the equatorial spin axis in green by bending the center line of the chain as shown in blue here that I'm highlighting on the insert there. And there's all kinds of reactions based on this initial movement. So there's going to be oscillations about that equatorial spin axis, both in the lateral direction, which is to the north and south, and there's going to be longitudinal oscillations about the equatorial spin axis, meaning like compression and tension in the east and west directions. So just by looking at this, you can see these oscillations. If you look at the main fractal, the chain there, you can see that counterclockwise rotation there, and you can see like a tension here longitudinally. You can see a counterclockwise lateral rotation and everything to the north, and even bulging a little to the south, and probably a slip and everything. And then what happens is the captain of the ship, the Southeast Asia Refold, after its arms got yanked out, as you can see in the insert, you can see that curling up of the arms. So after its arms got yanked out, the south arm re-anchored to the inner Earth, and the north arm retrieved the Russia Refold, as you can see here that I'm highlighting now. That's when it retrieved it. So there's this effort to maintain equilibrium about that equatorial spin axis. So everything comes together at that point. So there's no more tension, as you can see at the far end of the north. In fact, there's more compression now to kind of make up for that tension. So there's that oscillation. So there's compression in here, and then tension, and then compression. So there's your oscillations. And then, you know, there's an effort to maintain the equilibrium laterally too. So there's this kind of springing back and forth laterally. So there's counterclockwise rotation initially with the impact, and then Southeast Asia brings it back, but there's still this counterclockwise rotation to the south now, because before it went to the north. And then there's like the derailing of this train action, so to speak, where I'm showing the arrow now in that area. And as you can see, the Southeast Asia Refold, which I'm going to highlight in red now over here, that stayed attached with the one leg, the south leg, at the equatorial spin axis right over here. So that's why it's sort of the captain of the ship trying to maintain that equilibrium. But at this point, it's too late after this derailing here that I'm now showing in red right over there. And now the refolds are behaving like individual refolds. They're not bound to anything. They're more independent, as you'll see. But, you know, bottom line is that asteroid impact really initiated the tectonics on Earth, this early regime here. And you could even see in these to the left, you can see these mapping diagrams here that I'm circling. You can see whether it's minerals or rock types, there's this this relation to the impact. See here, there's this circular thing going on here, circular thing going on here. You can see the red arrows like moving in a pendulum-like manner here. So there's that counterclockwise rotation at the impact site, and everything's rotating around it. Eventually, as you'll see, I'm not going to describe these what's below here yet, but just by looking at it, you can see rotation is kind of the central theme here. rotation about the impact site. So in conclusion, it's obvious that the asteroid impact had initiated tectonics. Okay, this slide shows the great fractal that shows the 3 revolutions around the Earth after major tectonic events, and the 7 refolds are repeated 3 times, from time going from the northeast to the southwest in this direction here. And as I said, there's, because of the asteroid impact, which is shown in blue at the northeast end, I'm highlighting it here. That was the one that showed the different phases, by the way, that as it got compressed. But after the asteroid impact, there was all this oscillations laterally and longitudinally off the equatorial spin axis, which is shown in green. So the Southeast Asia Refold attempted to stabilize everything as sort of the captain of the ship, like I said before, and it's always anchored to that equatorial spin axis. At one point, there was 2 arms in there. They got yanked out. One went back in. One pulled the Russia Refold back, and then it just, one of them remained in up till today. But anyway, in regards to these text boxes here, as I said before, Kenosha existed from 633 to 573 million years ago, which is right in the heart of all this going on between 670 and 550, as I show here. That was when land was concentrated at the north and south poles and was connected by only a thin strip of land at the poles, according to geologic literature. So that's what happens with this lateral movement in particular, because the lateral movement is to the north and the south off that equatorial spin axis at the equator. This fractal may demonstrate much of the existence of the Pan-African orogeny between 650 and 500 million years ago. And there's a great deal of tectonic activity associated with the attempted lateral and longitudinal stabilization of the chain of refolds, as per my model. So undoubtedly, these tectonic events that are shown here in this fractal were associated with the Pan-African orogeny and in Kenosha, the supercontinent. Okay, the next several slides involve early tectonics from about 800 or 750 million years ago to about 550 million years ago. These slides show fractal details of dynamics and other observations, such as how we're living in a time warp and how the Earth is likely expanded. Okay, what we got here is something that you should take a look at in PDF form, because it's illegible here. There's a lot of description, very good, accurate description that describes the whole tectonic regime originally when the Southeast Asia Refold and the whole system is trying to maintain equilibrium about the equatorial spin axis, which is shown in green. And it actually talks about the future regime also in the lower paragraphs over here. And the lower fractal is discussed too. This is the what later became the Theia impact when Rodinia landed on the Earth, but this is the release of the moon in orbit by Rodinia. And Rodinia still has that top cone. There's 2 phases of it shown. So it's about to release the moon and head towards the Earth. And once it landed on the Earth, you have the fractal above. So, and that was affected by the destabilizing factor, which is the asteroid impact in Canada in the North America Refold. So you have those dynamics based on the reaction as things oscillate longitudinally, which is like this way along the equatorial spin axis, and laterally, which is that way to the south over here and to the north over here. Everything's an oscillation. That, you know, when it does one thing, it goes, if it goes one way, then it goes the other way. It's this oscillation. Okay, so these things are discussed in detail in this. You have to just see the PDF, which is, there's a link to it in the beginning of this presentation. So keep in mind that with these fractals, considering this is 2 fractals, it's basically one thing going on the bottom and then another thing going on at the top here, the second fractal. So time advances for these fractals basically in a counterclockwise direction as such, as I'm showing. So you have your older fractal here, and then you have your 670 to 550 million year old fractals here. It is broken up in the general vicinity, but things advance to the north and west. And in fact, there's another one over here just of North America where I'm circling. Take a look at the fractal at the top. It's just to show it easier, I circled. Now I'm highlighting exactly where it is. It's right in that, just off the chain there. That's another one as we advance to the northwest in a counterclockwise direction. Okay, this is a very important slide here. It's basically I'm going to describe the whole dynamic of that Nova Scotia fractal, which is shown the main featured fractal here in the right. Putting a check there. First, I want to go through the text boxes just to get a brief introduction in, and then I'll describe everything in detail. So if we read this one here, the chain rotated counterclockwise from the asteroid impact and then oscillated laterally and longitudinally in an attempt to remain centered and balanced about the equatorial spin axis, which is shown in green. The Southeast Asia refold remained fixed on one end, its original south arm, to the inner Earth at the equatorial spin axis. Note, at approximately 550 million years ago, around the beginning of the Cambrian explosion of life, the individual refolds moved independently of the derailed chain and in a counterclockwise manner to begin the assemblage of the supercontinent Gondwana, which is the next step in time. The Southeast Asia refold remained fixed at one anchor to the inner Earth at the equatorial spin axis in green. That's the still remaining anchored today, and it's the original south arm, like I said, and then it got spun up to the north end of the equatorial spin axis later, as it is today. When I say spun up, I mean rotated. And you'll see after this presentation, I get into detail on that because that's in the Cambrian when it starts to rotate. So this inset that I'm circling, this fractal in Maine of the Pangea breakup about 105 to 110 million years ago. This is after the train derailed, so to speak, and I'm going to talk about that on the right. But this is when the refolds were independent and they're moving around laterally and all that as individual units. They're trying to get into a access zone to the suture where the Southeast Asia arm sutures to the inner Earth. They're trying to get in there, and there's some access zones in the area that they're trying to get through. There's the attraction through those zones. I'll discuss more of that later. Okay, so this main featured fractal on the right side, the top of it is about 670 million years old, and the bottom representation is about 550 million years ago. All right. There are 21 of these land masses shown, which is really 7 of them repeated 3 times. And the reason they're repeated is because these fractals show the high energy events. So that's kind of what's guiding it. So there's like 3 cycles of time, so to speak, that I say here. And from the top, Southeast Asia refold is the one at the top. This is another fractal later that I'm highlighting. That's like a 525 to 550 million year old fractal when there's a full compression of the North America refold structure. So it's a fractal of that. But below that, it's just below where I'm highlighting now in blue, in this purple here. That's the Southeast Asia refold. So in order from geographic northeast to southwest or east to west along that equatorial spin axis, which is rotating to the east. So time goes from east to west or northeast to southwest in this diagram geographically. So top refold is Southeast Asia, then Russia, North America, Africa, South America, the combined refold of Antarctica, Australia, and India, and continent A. So again, repeated 3 times. So there's 21 of them here. So the asteroid hits like 800 to 750 million years ago. Not sure exactly when. That's my estimation. That's the destabilizing event, so to speak. That's the thing that tries to mess up this equilibrium about the equatorial spin axis. The stabilizing thing, as you'll see, is the Southeast Asia refold structure. It's like the captain of the ship that tries to pull everything back to that equatorial spin axis, and it sort of regulates the movement laterally and longitudinally. So laterally would be to the North Pole and South Pole, keeps things on that equatorial spin axis away from too much movement. and also longitudinally, which is along the equatorial spin axis. This thing, you'll see it's going to rebound like a slinky, so to speak. That toy is these oscillations, both longitudinally and laterally. Okay, so the asteroid hits, and that's shown in the blue fractal. You can see it's very small, but it hits left of the center line, or you can say north of the equatorial spin axis, which is the original center line of the whole chain structure of Rodinia. So it bends the axis, which is shown in blue, bends it in a counterclockwise manner, even bulges to the south of the equatorial spin axis a bit. And this motion was so violent that even the two legs of the Southeast Asia refold got yanked out, and it coiled back. There's a whole dynamic there where the legs coiled in, and even the geologic structures shown here, which are hard to see. There's an echelon structures, and they indicate that those legs pulled out and that the Russia refold went flying in a counterclockwise motion there. So there's a little bit of proof of that. So now the Southeast Asia refold has to sort of stabilize everything because it's got to control everything. It's the stabilizing factor here. So what it does, the south, or as you can see in this diagram, the right leg or arm, whatever you want to call it, it anchored down to the inner Earth where it was, and the other arm on the north side of the equatorial spin axis, or the left side here, it actually pulled back the Russia refold to the equatorial spin axis. So here, where I'm highlighting, is that phase here. That's the Southeast Asia refold pulling the Russia refold, which I'm now highlighting. It's pulling it back. And there's a whole dynamic there that shows that there's compression. It's subdividing the Russia refold into sections and everything. There's a detailed dynamic described, and it's PDF on that and everything. So while that pulls it back, while the Southeast Asia refold pulls it back, there's even a dynamic that shows like sticking to it on the north, or I should say the east side of the Southeast Asia refold. There's a South Continent A refold that shows like a pulling, like a sticking to it. So that's just more proof. That's this one right here. That's the Continent A refold. So now everything's together again. It's even compressed. I'm circling the zone that's compressed here. So you had extension here, where I'm circling, then compression there. And with the compression, yeah, things got pulled together there in that zone of the stabilizing Southeast Asia refold, but it sprung back between the North America refold that I'm highlighting here and the Africa, which is combined right now still with South America that I'm highlighting. So it pushed that back longitudinally, and there's extension now in this whole area. So the next sequence is longitudinal extension. So from a lateral movement standpoint, I drew a blue arrow here that I'm highlighting, which is now red. See, it comes to the fixity point, this whole chain structure. This blue arrow is like a segment that is showing the couple refolds center line for that brief time period, so to speak. It shows the center line for from the fixity point at the Southeast Asia anchor points. You got the Russia refold kind of above that. Then you got North America and Africa and South America combined refold there. I drew that as that blue line underneath there. So that segment is really a part of this yellow segment here, because you see these two refolds here that I'm drawing an arrow to. That's the one here is the combined Australia, Antarctica, and future India refolds there. And the one below is the Continent A refold. So they're out a little bit on the one side of the green equatorial spin axis. And this whole system that I just highlighted, which was yellow, that system wants to maintain equilibrium about that axis. So being that these guys, these two that I just talked about here, they got thrown out a little bit to the south of the equatorial spin axis. Remember, south is to the right. So the combined refold over here of Africa and South America, it wants to get to that yellow line. So it does like a twerk to the right, and it doesn't know its own strength. So these guys go flying over here laterally. See that? And keep in mind one thing. Remember, if anything, based on the shape and what happened throughout its history, as you saw on those globe fractals, the inner Earth fractals, some of these structures are, they're going to be more stable and less stable. The more stable are going to be, as I said before, Africa and South America, because they were attached, kind of looked like they were really one structure. And then the less stable would definitely be Russia, as you saw, and continent A. So continent A, I'm highlighting here. See that? So that guy went out, and the oddly shaped Antarctica, Australia, and India refold also went out. So you know that those were not going to be stable. So sure enough, there they go from that twerk. They go flying out. Then the system has to come back, and being that Southeast Asia arm is anchored, the south arm is anchored, despite the effort, there's this violent movement from that twerk, but it's still attached, as you can see, as I'm highlighting here now. That's the Southeast Asia refold. It moved to the right, but it didn't go anywhere because it's anchored there. And the next step, because it went this way before in a counterclockwise direction, now it's got to go clockwise, and it's also going to compress because it was extended before. So that's what's going on here. So the dynamic is going to be, see this blue arrow I'm drawing at the bottom? It comes up, it's going to go right through that equatorial spin axis and unite with the yellow arrow. So there's like a nice flow there. It's like a swinging pendulum, so to speak. And it's got to be going to the equatorial spin axis at the arm of Southeast Asia refold. So that's what it's doing. So you can see the application of brakes. Also in the section I just talked about, I'm highlighting now. You see these arms here? They're applying the brakes in the direction of movement, so it doesn't go too far, so to speak. And especially you can see that application of the brakes laterally from this guy here to that guy. See that right arm? And even the left arm comes down, so it's indicating that flow in that direction. So you know there's that time sequence. All right. So as it advances in time, you see how both arms are up on the continent A refold here that I'm highlighting. That's because it's actually getting ready to go the other way. So it knows it's got to go back, so it's already putting on the brakes on the left side. So that's why they're both up on the left. And the continent A refold there. So things come back, and then they go this way, sure enough, and you see the arms coming up. I think the action was so violent that you see like a tailwind thing here going on. And I'm circling here. This is North America refold. And you see such a severe, where the arm goes up, it actually got bent there. It was so severe on the North America north side arm. And I put in the blue arrows, so everything's going up like I put on the brakes thing over here, the whole thing. And then it's gearing up to go this way. See the arrow? It's gearing up to go counterclockwise. So you know that because there's a time sequence here. This is the Africa refold here, still combined with South America. So the arm is up there, and then it's going to go down to kind of get ready for that flow this way. It's got to do an aerodynamic thing to help it out to go that way. But the whole system doesn't want to go too quickly, so it's going to develop these arms here as brakes once again as it goes that way. So now the chain is officially derailed. I mean, even in this area with that twerk where I'm putting the arrow, it's officially derailed at this point. And the next step will be a relaxation from this compression zone that I'm drawing the arrow to at the end, at the west end or the southwest end, there's going to be a relaxation longitudinally, and there's going to be a rotation counterclockwise to the right. That's the next step in the Cambrian. Okay, this is the same slide as the previous, showing the middle reaches of that whole dynamic where there's an effort to maintain equilibrium about the equatorial spin axis, which is shown in green here. So in the first event, what happened was there was the asteroid impact in Canada in the North America refold, and that was left of the center line of the axis of the chain, so everything got pulled this way, and it actually snapped and slipped and bulged out, as you can see in the blue line here that I'm circling. But it caused longitudinal tension in this zone, and again there's this oscillation, so if there's tension, then there's compression. If there's lateral movement to the left, then it's to the right, etc. So on that note, you had tension, longitudinal tension in the upper zone that's cut off here. And now you're going to have compression, as you see here, and I'm circling, longitudinal compression. And then you're going to have tension again. And then it goes back to compression at the bottom of this fractal just before 550 million years ago. But on this slide in particular, I want to talk about what I wrote in the text box here. The Southeast Asia refold was critical in maintaining stabilization about the equatorial spin axis, which is shown in green, by pulling the chain back to the axis with one of its arms, while the other arm anchored to the inner Earth at the equatorial spin axis. That's always the fixity point. It's going to the equatorial spin axis at the inner Earth. Note the pulling of the bottom of the adjacent continent A. That's right here just to the northeast. To the northeast during the pullback process. It was sticking to it, and it kind of bulged here. You can see that arrow. Okay. Stabilization was also maintained by the refolds applying the brakes laterally, which is to the south in this case, on one side of the equatorial spin axis. There's actually shows a phase thing going on here with North America, which I'm highlighting here. It went from the red outline to the yellow outline. So as it rotated laterally to the south this way, the arm grew to sort of apply the brakes so it doesn't go too fast, too far and too fast. I should note here that where I'm showing the arrow, where the north arm pulled the Russia refold back, you could see on the Russia refold below here, you can see that there's like internal deformation, which indicates like a propagation from the geographic north to the geographic south here. So there's definitely that action of contact and propagation internally there. And you know that basically, the one arm pulled the Russia refold back, and you say, well, how do I know this went to the center of the Earth, the other arm on the south, which I'm circling here? Well, first of all, there's always that fixity, and you can see as I'm discussing this dynamic through all these slides, discussing what all these lines mean, but you could actually see it curving down here. It's anchoring to the equatorial spin axis, and it's not making contact as shown with the Russia refold. It's because it's digging down, so it's going to sort of make that that lineation or whatever that you can see in the fractal if you look very carefully. And this is all blown up, this whole area with Southeast Asia and Russia refold. It's blown up in one of the PDFs. You can check it out. So basically what's going on, as I'll be discussing and everything and have discussed, there's that effort to maintain equilibrium about the equatorial spin axis, and that's longitudinally and laterally. So as you see here, the Southeast Asia is trying to stabilize the chain back to the fixity point at the equatorial spin axis. And previously there was the tension, and there was counterclockwise rotation, much of the continents to the north, some to the south, with a bulging and an actual slip in the axis, which was shown in blue and still is shown in blue here on this slide. So now there's that swinging action going around, so it wants to rotate still counterclockwise, but it wants to rotate laterally to the south of the equatorial spin axis, which is to the southeast on this diagram. So that's why I drew in Um, the blue is showing the center line of the part of the chain between like North America here, what I'm checking, and Africa and South America. So there's like segments to the chain, but basically on a larger scale, the Africa and United South America refold want to get to this yellow line here because this ends up going through the fixity axis again with the Southeast Asia refold. So it says I want to get at least to this yellow line. So I'm going to make an effort to get there by this arrow here that I'm highlighting. So I got to do like a little twerk to get out there. And what happened was it didn't know its own strength and went too far, and everything went flying this way, which I'll discuss later. Okay, I'm going to talk about the Southeast Asia refold here again, the dynamic with its anchor and everything. So reading the text box, the refold separated longitudinally about the equatorial spin axis after the Southeast Asia refold pulled the chain back to the equatorial spin axis with its one arm as one re-anchored to the inner Earth at its equatorial spin axis. The one that pulled it's right here that I'm talking about. See, I'm circling. The one that pulled the Russia refold back was a north arm. North arm is here. Russia refold is below here. It's blown up down below. So I'm saying that the refold separated longitudinally. You can see that I discussed this before, but that longitudinal separation there because there was a compression. There's this oscillation compression to tension here to this bouncing longitudinally. And anyway, the Africa and South American refolds were the last to separate. So here's Africa and South America. But what I'd like to talk about is how do I even know that the one arm, the south arm of the Southeast Asia refold anchored down? Well, just based on this drawing here, if you look here, it's not making contact with the Russia refold, which is below right here, Southeast Asia refold here. So here it is. It's evident that there's that contact, that pulling in, and there's even in the compressional signature here of these this interior compressional signatures. You have to look at the PDF to get more detail. This is in a PDF separately. You can blow it up and everything. So basically, when it's not in contact, it implies that it's just going down. And also, you can almost see an angle there that it's like reaching down like that. And again, based on the character of what happens, especially later when this thing starts rotating this way, this Southeast Asia refold. And even what you see today, it just looks like it's under tension. So there's a lot of evidence that it's just the one arm that remains attached today. And this one here, the north arm, never did reattach. Okay, on this slide, I just want to start talking about the oscillations again with the chain. The Southeast Asia refold is like regulating the movement, and there's longitudinal movement, which is shown here northeast southwest. It's really east west along the equatorial spin axis, which is shown in green. There's tension here right after the asteroid impact here. Then there's compression. Then there's tension. Then there's compression here. So there's this oscillations that are operating under a time warp. And there's also lateral movements to the south, which is to the right, and to the north, which is to the left. And at this point, you can see the Africa and South America refold are still attached, and eventually they detach. But remember what I was saying, they this pair here, the Africa and the South America refold, wanted to get to that yellow line, so they did like a twerk, like a quick movement or whatever, to the right, to the south, and they blew out these refolds here that I'm circling. And Southeast Asia refold held on to dear life because you can see that yellow arrow there. It went in that direction to the south, but it's attached at the south arm is attached to the equatorial spin axis here where I'm highlighting. So that's what stabilized it. But the chain was officially derailed at this point, and now it's swinging laterally to the south as shown by the yellow arrows, and then it wants to go back the other way in the blue, as you see. So it's officially derailed, with the exception of the Southeast Asia Refold, which is still connected by one arm at the equatorial spin axis. So if you look below in this diagram, this is a diagram of Earth today, and I show two zones here that I'm going to circle. This is a damaged crustal zone, I believe, that is a gravity anomaly today, and that happened later. We'll talk about that later, like 105 million years ago or so. But the one right here that I'm about to circle, that is just on the north side of the equatorial spin axis. See, here's north, and that's a gravity anomaly today. And really, it all originated from what happened here, where I'm pointing here after the famous twerk by the African attached to South America Refold. So basically, the action of the Southeast Asia Refold just moving and its anchor probably bulldozing the brittle crust near the surface. So it caused some damage, and that damage caused greater attraction to the suture zone at the equatorial spin axis, really at the center, at the connection at the suture at the inner Earth, where that Southeast Asia south arm connects. So as these refolds went laterally, they sort of were able to feel that attraction more, and they start moving towards that area, and as you'll see later in the other geochronology slides after this one, after this part, which is only the Precambrian. But anyway, it looks as though there was, in fact, that damaged crust there from that. So you got to wonder, why didn't it happen earlier when the Southeast Asia, where I'm putting the arrow to here, where the Southeast Asia arm reached and got the Russia refold, dragged it back to the equatorial spin axis. Well, there's no gravity anomaly there now. I don't know if things have healed up or if it was just that it was very ductile and hot at the time, at this earlier time. Remember, time advances to the southwest. The closer to 670 million years ago is at the top. So maybe things were ductile then. And in regards to expansion of the Earth, well, first of all, it was maybe that north arm didn't want to go back down because it was too brittle to get access to go down. Like, things started to get more brittle as you went further south, and after that twerk that I was talking about. So maybe that north arm could not get back down because it was too hard and brittle at the top, or maybe because the Earth is expanding. We'll talk about that more later, but maybe it couldn't reach down anymore and had to rely on that south arm to reach down to the equatorial spin axis. But the dynamic, as you can see, as you will see later on, is there's definitely one arm attached. It certainly acts like that with its rotation and everything, as you'll see coming up, and the way it interacts with the refolds. Okay, in this slide, I'd just like to, again, just talk about how we are living in an extreme time warp. The train dynamic, as I described, with the tremendous lateral and longitudinal movements of the refolds, longitudinal in compression and tension along the equatorial spin axis, and lateral from pole to pole, perpendicular to the equatorial spin axis, which is shown in green here. With all this movement, it's over about 120 million years. As you see, 670 million years at the top and 550 million years at the bottom as time advances to the southwest, northeast to southwest. Just to note that I'm going to highlight the North America refold, the last version of it here, towards the south end. So with all these oscillations going on, the full compression of the North America refold was not achieved until later, after this fractal between 525 and 550 million years ago, as you saw on the previous slide with that fully compressed asteroid impact fractal and the subdivisions of North America showing what looks like Florida, and that's in fact when the Florida plateau was, according to geologic literature, when that started about 530 million years ago. So there's this delay time. It's just amazing. It couldn't even get that full compression until after these seemingly quick oscillations occurred. So after that full compression, then the North America refold decompressed, and it was allowed to rotate heavily counterclockwise, as we'll see later, but that's in the Cambrian. Okay, I'd like to talk about something controversial on this slide, the expansion of the Earth over time. It's been ridiculed pretty heavily by a lot of geologists. I think most think that the Earth has not expanded, and really the context of those that think it has expanded is basically something like a giant air pump pumping up the globe of the Earth, and then that's causing the continental drift. So I don't agree with that either, but I do agree that Earth expansion, based on my model, certainly is feasible. And based on like even the fractals, if you look at this insert here from 875 million years ago, this fractal that we discussed previously, just by looking at that and then looking at the globe today, because some of these refolds are still relatively intact and you can kind of estimate their size relative to the diameter, the size of the globe. So it looks as though, yes, there was in fact a smaller Earth back then, 875 million years ago. So we're going to now read this text box and try to follow me. It's just speculation here. Another thing that I did not discuss here, actually, before I read this, the Southeast Asia Refold arm. Now, the two arms came out, as I discussed, after the asteroid impact, and then the one arm, the south arm, went to the inner Earth and sutured onto it, and then the north arm retrieved the Russia Refold and brought it back to the equatorial spin axis. So that south arm of the Southeast Asia Refold is still there at the suture, and the north arm is not there. So for whatever reason, whether it's the expansion of the Earth and it couldn't reach down there, or whether it was just the upper crust was too brittle to penetrate, whatever it is, only one arm remains sutured to the Earth today, ever since that time when it pulled back the Russia Refold. That's shown in this fractal. So now if we look at the text box here, I'm saying, reading off, the expansion of the Earth is demonstrated in the views from northeast to southwest in the direction of time advancement, or from east to west based on the green rotational axis. First view, which is actual head-on view, which is in the box I'm about to circle here. Okay. That's Southeast Asia to the combined refold of Antarctica, Australia, and India. This is 6 refolds, which is 1 refold less than the full time cycle of 7 refolds around the Earth. Okay, back to this text box here. The second view is the other side of the Earth and corrected here to match the actual view. This was a flipped view that I put in, and this goes from continent A to South America. I'm going to circle that in a second. This is also 6 refolds and 1 less than the one less refold than a full time cycle around the Earth. So here's that right here, this whole zone I'm circling. Should be noted the first and second views have been moved and adjusted from the actual location where they're found on the globe in nearby North Nova Scotia to match the chain to the southwest west. So I built up this chain, this dynamic from the whole south end of it. So the third view, the south end, reading here, actual head-on view, nothing flipped or whatever. It's Antarctica, Australia, and India combined refold to continent A at the south end, the very south end. This is 9 refolds, which is 2 refolds greater than a full time cycle around the Earth. Now, possibly as Earth expands, more refolds can be seen in one view. These fractals, views, or photos, I call them, they reflect the fact that light can bend around the globe, and it will bend more easily around a larger globe with a lower degree of curvature. The fractal is estimated to be 670 million years old at the northeast end to 550 million years old at the southwest end. Okay, Earth geochronology continued. This is the late Precambrian era, 550 million years ago to about 541 million years ago when the Cambrian started. Okay, now we're at about 550 million years and just after. We're getting to the very end of the Precambrian, which ended, I think, about 540 million years ago. So here's the previous fractal that we kept seeing. The bottom end of it is about 550 million years ago. And It's got to reiterate that the Pan-African orogeny, this straddled the Cambrian and the Precambrian. It's the, I'm saying in the text box here, the resulting compression or release of the interlocking mechanism, really at both sides, two of them, and the dynamic associated with the Canadian asteroid impact resulted in Pan-African orogeny, which appears to show internal refold reactions. As you can see in this diagram here, shows the locations of mountain building. The Pan-African orogeny and the Grenville orogeny are the largest orogenies or mountain building events on Earth. So I believe basically, in general terms, the Pan-African orogeny is just a result of all that oscillation of the chain of refolds. So now if we look at this bottom drawing here, that's just after 550 million years ago. As I said here at the bottom, the refolds are from top to bottom: Southeast Asia, Russia, North America, Africa, South America, combined Antarctica, Australia, India, and other land, and then continent A at the bottom. Okay, so just to note here, here's the anchor to the inner Earth from the southern arm of the Southeast Asia refold. So again, I can't stress this enough. Look at the differences between the two, the fractal above and this drawing, and everything will make sense. So I wrote in the text boxes, rifting began, highlighting, at these locations 670 million years ago, as per geologic literature. So the geologic literature is going to agree with my model, just because of these basic oscillations and things that I was discussing. This is due to severe snapback after the locking mechanism released, refold dynamics. Everything comes down to refold dynamics. So on the next text box here, oscillation longitudinally and laterally about the rotational axis where the refold chain is pinned continues. And springback from the locking mechanism continues, particularly with the Africa and attached South America refolds. The train-like dynamic has now derailed because the chain is only pinned down at one arm anchored to the inner Earth after the Southeast Asia refold's second arm was released from the inner Earth, allowing it to freely rotate at this point. This is key to the future slides. Southeast Asia refold, since it only is pinned down at one point, it's going to be rotating now. Okay, according to geologic literature in this text box here, South America rifting begins, which is just below. This is South America here. South America rifting begins and then quickly reversed to ocean shrinking as per geologic literature. This is due to refold dynamics. See above previous fractal as to why longitudinal and lateral oscillation about the rotational axis. So you see how things are just springing along. So as things are oscillating and the arms are swinging around, that's when the oceans open up or close. And at this point, there's this, as I say in the text box here at the upper right, there's now longitudinal relaxation about the spin axis, and lateral counterclockwise rotation continues about the spin axis. Reading the text boxes again, structures snap back from locking mechanism to some degree, still snapping back from that locking mechanism, especially the Africa and South America attached refolds. So these are Africa and South America. And the Iapetus Ocean opened up 670 to 550 million years ago as per geologic literature. That's basically the whole fractal we just showed, which is from Nova Scotia. And the Iapetus Ocean is shown here now. All right, on this slide, it's basically a summary, very brief summary of everything that's been discussed thus far. Have tremendous agreement between published geologic literature, showing a time scale here, showing a 2-scale duration of these events. And there's a description of geologic literature on the left side, color-coded in words, and then my model claim here. So not a lot of detail is given. It's all been discussed, but you see the tremendous agreement. between the geologic literature and my model. So I'm not going to go through this all, but it's just a clear, concise summary that you can take your own time checking out.